Welcome back to Lemaster Tech, and in today's video we are going to completely rebuild classic Donkey Kong in Python using the PyGame module. So I am so excited to code this entire project with you guys line by line because it is one of the most fun and challenging and unique projects I have ever built, and I think you guys are really going to enjoy it. But just quickly, before diving into the tutorial and the showcase, I want to give some quick thank yous and shout outs because we just hit 5,000 subscribers on the Lemaster Tech YouTube channel, which is so awesome. And I know that we're just getting started as a channel, but I'm at 200 videos, almost 2 years of uploading, and I would not be able to be here and be this size and growing this fast without all of you viewers and all of the subscribers who leave constructive and helpful and nice comments and come back to the channel time and time again. Some special shout outs to Fleo Inc. and Coding with Sadra, who comment on practically every video and have been longtime supporters of the channel. And massive thanks to Philip Nunez and Dale Topley, my Patreon supporters. Dale in particular has been commenting on videos and supporting the channel since I literally had like 100 subscribers. So special thanks to all those guys. Thank you guys so much. Now let's do a quick project showcase of Donkey Kong here, and then we'll dive into the tutorial of actually building it. I actually use PyGame's native drawing tools and a bridge and ladder class to procedurally create all of the platforms you walk on and all of the ladders that you climb up and down in this game. Then we import a lot of classic retro Donkey Kong images for Peach and Mario and Kong, as well as the barrels, the flames, and the hammers that you interact with in this game. We use PyGame sprites and sprite groups for barrels and flames and hammers, as well as the player, so that we can apply shared code elements available to all sprites to all of these objects. We animate Mario so there's different images for when he's climbing, when he's running, when he's jumping, when he's standing still, and when he's using the hammer. You lose a life and the whole level resets anytime you collide with a barrel or one of the flames that is chasing you. And then you get points for smashing barrels with the hammer and jumping over barrels, as well as a time-based bonus, so the faster you complete the level, the higher your score. We then track your score against previous high scores, and we see, ultimately what the highest score you can get on this level is. All in all, this project is really close to how level 1 of classic Donkey Kong plays. It's over 700 lines of code. It takes a little more than 4 hours of really heads down programming. So you may want to keep track of your place with comments that are like bookmarking, or write down where you are in the video. I know just finishing this 4-hour crunch in one session is maybe not realistic for some of you guys, but I hope that you can get through it. It is a ton of fun. It is super rewarding. And all of the code that we write in this video, as well as all of the image assets I use, are in the GitHub link in the description of this video. So be sure to grab that if you want to follow along. My Patreon link is also down there if you feel like becoming a super supporter of the channel and the work that I do. Now let's get into this tutorial together, and don't forget to leave a like and subscribe to the channel if you're really enjoying building this project with me as we go through it. So let's get right into it. Okay, let's dive right into this build. I'm sure I just gave you guys a killer introduction, and I am super stoked to be building classic Donkey Kong with you guys for 5,000 subscribers. That is amazing. So we're going to import the OS, random, and PyGame modules for this game. The reason we need OS is because I want to make it somewhat dynamically resizable. So I know for Pac-Man, which was another really popular game we did together on the channel, a lot of people didn't have a screen as large as mine, and they were having issues scaling it down, and we didn't do a great job of making that sort of resizable to whatever screen that you're using. So we're going to try to do that in this game. It's really hard to capture every single item that we draw and make it all dynamically resizable, but we're going to do as much as we can, okay? And so we're using OS, and just there was a really recent video where I talked a little bit more about how to do a full screen PyGame game. So if you need a little bit more background on this first setup step, go ahead and check that out. But you're going to use this os.environ, which is environment, and just say SDL_video_centered. This is going to allow us to get information about our current screen and use that in building the overall game. Set that equal to 1, and you are supposed to call this before pygame.init. We're going to use this information in our pygame.init. Okay, so now pygame.init, just like that.
And then a few other just beginning setup things. So info is going to equal pygame.display and then capital I info. And this is something that we use to get the screen width and screen height. So we have this screen underscore width, comma, screen underscore height. And we are going to set that equal to that info variable we just made, current width, comma, current height, info dot current height. So these are PyGame's way of getting the information about our screen. Now, what I want to do, because PyGame or classic Donkey Kong does not need to be full screen, it was a very like pixelated low def thing. So I'm actually going to create a separate variable window width and window height. If you want Donkey Kong to be full screen, you can just use screen width and screen height. But I'm going to create new variables window width and window height. And I'm just going to make these kind of adjustments off of the variables we just got. So screen width, I'm going to do -800 because my screen, I think, is set up to be 1920 by 1080. And Donkey Kong is more or less a square. So then I'm going to make the height, screen height, -150. So I'm going to have quite a margin on the sides. But it's going to be almost full screen up and down. We don't want it to necessarily like overshadow the top and bottom title bars, but that's how we're going to do that. So that's us setting up our screen. We want to make sure two things that you need for basically every PyGame game if you don't want to like overclock your computer is set up a clock and set up an FPS, so a frame rate. So do timer equals pygame.time.clock. And then we're going to build at an FPS of 60, so 60 frames per second. And we're going to use those once we get into our main game loop, as I like to call it. A quick note, I imported the random module. We're not going to need that for a little bit. We're going to use that to add a little bit of RNG for like the fire sprites that pop out and the barrels. So we are going to use that, but we're not going to need it for a little bit. That is why it's grayed out on my screen. Okay, now let's go ahead and do pygame.display set caption, and let's just call this classic Donkey Kong rebuild, just like that. That's a good title, and that's gonna show up in the title banner of our game when we boot it up. A quick note, some of you ask about this. I'm not going to change the icon, but if you want to change the icon in the top right, it's pygame.display.set icon, and then you point it at an image file here. And so that is how you change the top left icon if you want. I don't really worry about that too much when I'm building like personal games for fun. Okay, so all right, now let's actually use the window width and window height that we spent all that time getting. So let's do screen equals, and this is going to be pygame.display.set mode. And anyone who's built a few games in PyGame knows that all you have to do here is give it your width and height, so window width and window height. And this is just essentially setting what your screen variable is going to be for the rest of the game, and the screen is what we draw everything onto. All right, and now just so everyone knows what I'm building based off of, I got this image and I found a YouTube video of a guy playing this version of Donkey Kong. I've seen a few different ones. There was like a Japanese version, an American version, an arcade version, an NES version. So there's a lot of different versions of classic Donkey Kong. This image, which will be included in the GitHub package linked below, is what I'll be designing the level based off of. And to talk about a little bit of what we're seeing here, it's actually kind of interesting. The width seems like it lends itself to a tile-based drawing style really well. There's just kind of 32 squares across the screen overall, and basically everything that gets drawn onto the screen falls pretty well into those, but you can kind of tell from the ups and downs, it doesn't make a ton of sense to use like tile coordinates for up and down, because there's this sort of slope going on for the platforms. Even though each of them is actually a horizontally drawn object, they are not a full like section off of each other. So what I'm going to do is I'm going to break the overall screen into a section width just based on the total number of tiles I'm going to have. And then I'm going to call basically the height of one of these bridges, one of these platforms. I'm going to call that my section height. But I'm going to need a secondary variable that I'll call slope to essentially define this offset, right? So however much our platforms are changing in height, it's not a full section. It's some slope, and it does appear to be constant across the entire board, which is nice. So let's go ahead and create a couple variables here underneath the screen that are going to be really, really important. So let's start with section width. And remember to make this to where it works on your window, even if it's not the exact same as mine. I'm going to go ahead and make that my window width. So whatever I just defined as my playable space, and then floor division 32. So this is going to round down to the closest whole integer, and that is going to be the width of each individual section. And then I'm going to make section height a separate variable because it's not going to be a perfectly square screen for everybody. So we're going to use window height. And again, floor divide by 32. So you can kind of picture the overall board broken up into like a tile grid of 32 by 32. But now we're going to have to do something extra, and that's define this slope variable, which I actually want to be section height divided by 8. So let's talk about that real quick, because once we're up and running on drawing the board, we're just going to move, and I'm going to assume that you kind of understand what we're talking about. If you were to trace, like with a ruler, which I literally did, from the top of one of these platforms to the bottom of the first platform that is actually above it, you find that you get these 8 step changes. So 1, 2, 3, 4, 5, 6, 7, 8. And then over here, the bottom edge of this lines up almost perfectly with the top edge of this. So what I'm going to do is say that that slope is equal to 1/8 of the section width, okay? And setting these variables up in the beginning is really going to help when we get into our draw board function, which is almost the first thing that we build in this game, okay? So let's go ahead and move on from this. I know we want to start putting things on the screen as quickly as we can. So let's maybe set up the main game loop, and then we'll be done with kind of the boring like boilerplate setup stuff, and we can get into the more exciting stuff. And so when I say main game loop, this is the while loop that runs the whole time our game is playing. So we need a variable to keep track of that being active. So we will just set run equal to true, and then say while run, do everything underneath it, okay? And so first thing I'll do is I will fill the screen with the color black. Almost every version that I've seen of classic Donkey Kong has just a black background. And then we're going to do timer.tick at the FPS. So this is the frame rate variable that we set up in the beginning, and that timer variable using pygame.time.clock. And now the only other thing we have to do to like just get this booting up to where we can see our window and see that it works is we need to set up event handling. And so let's start for event in pygame.event.get. We want to check if the event.type is equal to pygame.exit. Pygame.exit. But I'm goofing up. Sorry, guys. This is not a hard one. It's quit, not exit. There we go. And if our event.type is equal to pygame.quit, all we have to do is set run equal to false. Boy, it's really early in a long project to be messing up like that. Then we want pygame.display.flip, and this is still inside the while loop. This is making sure that everything we draw onto the screen gets drawn every iteration of our program. But then outside of the screen, we just do pygame.quit. Quit. And so that means we press the red X button and we want the screen to close. That's all that's going on here. But hopefully, if we haven't messed anything up, if I boot this thing up now, we're going to have a window that is 800 pixels less than our width and 150 pixels less than our screen height. We're not really drawing anything interesting onto the screen just yet, but let's go ahead and run this and see what we get. And actually, I got an error. Timer.tick FPS. Yep, so you don't put this in quotes, guys. That was my bad. I guess I was moving too fast. That just needs to be the integer variable. Okay, and hopefully you can see I've got just this classic Donkey Kong rebuild. That's what the title bar says, and I have kind of the minimize and the X out button, and it's a good size. Like, it's a playable, fun widget size. So let's go ahead and close that, and let's actually put something interesting on the screen. And something in a lot of my earlier projects that I struggled with, just because I'm self-taught and it takes a little while to get used to these things, is kind of abstracting things out. And so rather than rather than like drawing all of the items here, we are going to make a function that we'll call draw screen, and we will draw the platforms and the ladders there. So draw platforms and ladders on the screen in dedicated function, okay? And this is just a really useful way of thinking about it, is like, okay, I want to draw the screen. I don't know maybe right now exactly what needs to happen there, but I'm going to create a function that does something specific for me every iteration of my loop, but then I can come up here above my game loop and I can actually define what it needs to be up here. So we're going to define draw screen. Okay, and in this function, we are going to actually, so this is a function to draw platforms and ladders. Okay, so those are the two biggest things. We'll draw like the oil bin and Donkey Kong and the hammers and the barrels and Peach and the player in separate functions once we get there, and all the scoring and information. But let's focus on platforms and ladders. We will have 90% of this level built once we get all these platforms and ladders on the screen. All right, so let's take a look at the draw screen function. And the first thing I'm going to do is I'm going to create an empty list of platforms because we don't have anything drawn right now. And I'm going to create an empty list for ladders as well. So let's go ahead and say ladders, and I'll call this platforms list and ladders list. All right. And what we want to do is actually, I want to use PyGame's native drawing tools to draw the platforms and ladders. If you look at these, every platform actually is just a flat top and bottom level, and then two diagonal levels. And then every ladder is just lines, vertical lines on the side with a horizontal line in the middle. And so I think it'd be really cool to procedurally draw these using PyGame's drawing tools, rather than just importing an image, a pixel image of the platforms and ladders. If you don't like that, make your own. That's fine. But so let's go ahead and say that we want to draw each of these, and something that is really powerful that Python allows you to do is essentially create what's called a class for every platform and every ladder. And this is going to be really useful because we want you to be able, the player, to be able to interact with bridges and ladders in specific ways that every bridge and ladder are going to have in common. And this is the perfect time to make classes where we're going to define a class that's going to be a bridge just like this. So class and then capital B bridge is the Python standard. You don't actually have to make it a capital B, but trust me, that is the standard Python syntax. And it is definitely best to do it that way. The internet will come after you if you don't use caps on your classes. Okay, but then we're going to do a very special function that you need to do in the beginning of classes, which is define underscore underscore init underscore underscore. This is the initialization function inside your class. This is where you pass in variables. And so if you think about what a bridge needs for us to fully define it and draw it on the screen, it needs to know its x coordinate, its y coordinate, and then also how long it is. So if you look at these bridges, they are not all the same length. We have some on the ends here that are 2. We have some in the middle here that are 3. We have this first one that's like 15 long. The Peach platforms as well as the Donkey Kong platform have their own length. And so what we're going to do is we're going to pass into every bridge that we want to create and draw an x coordinate, a y coordinate, and how long it needs to be. And then we are going to draw it based on those variables. And so what we need to do is we need to create internal versions, basically internal variables that store this information that we pass in from the outside when we create the instances of these objects. And so self.xPosition is going to be equal to our x position that we give it. And remember, I'm going to define each tile in the x coordinate based on its section width. So let's just go ahead and take whatever we pass in and multiply it times the section width. And this is going to make a lot more sense once we start drawing them on the screen. But I'm going to give it a variable from 0 to 31, basically, its x coordinate in terms of section width. And we're going to multiply it internally to these classes. And then the self.y position is just going to be equal to the y position we pass in. It has to be a little bit smarter because we're including that slope. So we could give it like some integer value based on the slope. So broken down into like the 32 section heights we have and then divided by 8. But honestly, at that point, you're multiplying it by like 256 subdivisions. I would rather do the math ahead of time in my like list of all of the bridges. Okay, so now let's go ahead and say that what are we going to do with the length? We're going to make an internal self.length that will be just equal to this length that we pass in. And then if you think about the bridges, how does the player interact with the bridges? Well, the only thing the player does is they walk on the bridges. And actually not just the player, but the flames as well as the barrels all need to know where the top of these bridges are. So we're going to need to get the top of these bridges, but we'll get that from some other function that we're going to call self.draw, because it's not a good idea to do a lot of that drawing and confusing stuff inside of the init function. You just want to set up the original class in the init function. But so we're basically now we're abstracting further and we're saying, okay, we're going to handle all of this drawing stuff in a deeper level. So let's go ahead and make that self.draw. And remember, I said I want to be able to use PyGame's native drawing tools. I'm not just going to screen.blit an image of the bridge onto the screen. So let's go ahead and define a variable. And if you want to play around with style, this is a good variable to do it. So line width is going to be equal to 7. And then the platform color, this one I'm just sort of like, I like this color. I think it looks a lot like classic Donkey Kong. So I'm going to define a pretty special RGB value of 224, 51, and 129. And that's sort of something that I found. It's like a purpley pink sort of classic Nintendo color. But you could just do something like red or dark red. Here, if you wanted to, you don't need this RGB value, but I actually think this looks a lot like level 1 of classic Donkey Kong. So that is where I got this color from. I have the advantage of having built this ahead of time, more or less, so that's what I'm going with. Now, what we're going to do every length, right? So if we pass in a length of 1, we only need to do this once. But if we passed in a length of 7, we have to do this 7 times. So let's go ahead and say for I in range of self.length. Okay, so that variable that we store in self.length now. We are going to do what? We're going to have a bottom coordinate, a top coordinate, an x start, an x end, and then also a x middle. So you can think of this as bottom coord is going to be equal to that y position that we pass in, self.y pos, plus the section height variable that we define. So remember, we're telling it it's starting x position and starting y position. That's what self.y pos and x pos are. And so the bottom coordinate is going to be y pos plus section height. We're making the bridges exactly 1 section height tall. And then the x start, or you can think of this, I guess, let's say left coord to be consistent. I could hear some of you guys going, wait, bottom, top, and then x start and x end. Yeah, it's bothersome. Okay, so left coord, self.x pos. And now start thinking of this kind of like visualizing in your brain. We're going through this loop and we're drawing every horizontal piece of bridge. So self.xpos plus our section width variable times I, because we're doing a for loop where I is our index variable. And so every new chunk is going to end at section width times I plus section width, and it's going to start at section width times I, all added on to the self.xpos starting coordinate. All right, and so we need a mid coord, and this is the x mid coordinate. We don't need to use this for anything with our y platforms, but to look back at the bridges, we kind of have these diagonals that go from bottom left to top middle to bottom right, and so we need an x mid coordinate. Well, that is just going to be our left coord plus a half of the section width. And so actually, rather than do all of this math, let's just say it's literally our left coordinate plus section width times I. But we actually don't need section width times I. We need section width times 1/2. because we're doing the math of figuring out where to start the platform here. And so we can just say our middle coordinate is a half to the right of that. And if you're confused why we're setting these coordinates up in the beginning, just wait till we actually draw the lines. It's going to be a lot easier to reference these variables than it would be to have this stuff over and over again inside those shape definitions. All right, so now let's make right coord, and let's call that basically the x position plus section width. So we can take the exact same thing we did here, left coord plus section width times 1/2, and instead we can just get rid of the times 1/2 and get rid of these parentheses, and it is just the left coordinate plus 1 section width, okay? And you could use mid coord plus section width times 1/2, but that's kind of goofy. Let's just make everything based off that left coordinate, okay? And I think we can define top coord if we want, again, to be consistent, but basically it's just self.ypause. So this is the one where I'd say it's not exactly an optimization, but it's maybe something we should do for consistency's sake. So let's go ahead and put top coord in there. But in my opinion, if you want to not use top coord and you want to use self.ypause, that's totally valid as well. Okay, so let's start drawing these lines. Pygame.draw.line, we're going to put it on the screen. And so first thing you do is you give it a surface, and then you give it the color. And I'm going to use the variable platform color. So this way, if I want to change the color of every platform on the entire screen, I can just mess with this variable. If you put the color in every line, you're going to have to change it in every line if you want to mess with the style later. So it's a good idea to keep your style element somewhere that it's easily changeable. All right, and so this is the top line. So let's go ahead and do left coordinate, and then let's go ahead and give it the starting y left coordinate, which is going to be the top coord. And then let's go ahead. A line only needs two things, a start and end coordinate. And so this is going to go from the left coord to the right coord. Let's go ahead and put it on a second line. I want it to be easy for you guys to read, but I also want to keep big IDE text up. And so we're going to go to the right coordinate, but we're going to keep it at the top coordinate. So this is our top platform. And then I'm going to make all of them line width. Again, we're going to draw 4 lines here for every platform. So it's a lot easier to keep these in separate variables. It's sort of like putting your CSS separate from your HTML in web design. So you nerds should get that. All right, let's draw a second line, and this one's going to be really easy. It's the same x coordinates, but instead of top, we are going to draw bottom, and so that is our bottom line. And now we are bottom line, and then we are going to draw 2 more, and they're going to be the diagonals. So they're going to go from the x start bottom, left coord, bottom left, to top mid, and then the second line is going to go from top mid to bottom right. So let's make that in action now. So from left coord, bottom coord, to mid coord, top coord. All right, and now let's go ahead and copy that, and let's throw that down here. And this is going to go now from mid coord, top coord, which is basically where we left the last diagonal, and it's going to go to the right coordinate, bottom coordinate. Okay, so this is just a fun bit of programming here where you can visualize each one of these platforms as a top and bottom line with a diagonal set inside of it, and that's going to give us this little rectangular ladder. So we're not actually drawing any of them just yet, but remember what I said in the beginning. We're going to need a top platform to do all of our PyGame collision in. To say, okay, I'm standing on the top. And you can take a look at this top line. And so I'm going to say draw 4 lines, top, bot, left diag, and then right diag. So those are the 4 lines that we drew. But now we also need to get the top platform surface. And honestly, it's going to be a lot smarter to get this as a rectangle than a line, because in general, if you want to check that like your player's feet are on the top of a platform, using the pygame.rect collide is one of the easiest ways to do collision detection in Pygame. So I'm going to just preemptively get it as a rectangle. where I'm going to say that the top line or top surface, call it whatever you want, is going to be equal to pygame.rect.rect. So not draw.rect, .rect.rect. We're getting it as a rectangle, but we're not drawing it on the screen. And this means that rather than put all 4 arguments in square brackets like a list, we're actually going to pass it to tuples, which are going to be the X and Y start position, and then the width and the height. Okay, so the top line, X and Y start positions, are going to be the left coord and then the top coord. So this is the top surface of the platform. And then for width, I'm going to make it to where it is just going to be the whole section width. So we can just put section width here. You could also, if you're worried about this not being smart, actually, forgive me, we are just going to do this once for each platform. So rather than, if say this is 7 long, we're not going to pass back 7 little increments. We want one that is going to be as long as the entire thing. And so to do that, we need it to be kind of like our initial start position minus the total width. And so we actually need this to be self.length times section width. Okay, so I hope I didn't just lose anybody. I hope I didn't just confuse them. We are going to pass back one top line outside of this for loop that is going to be the entire width. And so actually we need these to not be left coord and top coord. We need this to be the root self.xpos and self.ypos, because we are taking the start position of the overall platform. So for this Donkey Kong platform, we're taking right here, and we want to return one surface rectangle for this entire thing. And it might seem like a small optimization because you could return all these small individual platforms, but extrapolating this out to an even bigger program, you're reducing the number of rectangles you need to check for collision with massively. So rather than this being 15 rectangles to check for collision with, we are just going to pass back one per surface. So move this outside of your for loop, start it in your overall shapes, X and Y position, and then make it the total length of the platform times section width. That's how wide it's going to be. And then for now, I'm just going to make it too tall. We'll check when we get to collision detection, but basically I want this to be like a thin surface on the top of my platform to check for collision with. And if you want to actually see the top line, you could do like pygame.draw.rect up here, screen, and let's make this a clear different color. Let's make this blue. And for now, I'm just going to draw the top line on there. I'm going to get rid of this in a little bit, but I think it's important that you guys see what we're drawing. All right, so let's return the top line, okay? And let's make that all that we do for now. And then let's come down into our actual draw screens list. So I'm going to minimize this bridge class for just a second to get it a little bit out of the way where my code's easier to read. Let's go back to our draw screen function because that's where I want to create these bridges. And so inside of draw screen, let's go ahead and say that let's just make one platform for now, and let's put it at like 50. Let's do 500, 500, just to put one out there. And so remember, every platform is going to get an X position, a Y position, and a length. So let's put it at 500, 500, and then let's make it 5 wide just to get this made, okay? And so let's go ahead and say for, I guess I called them bridges, huh? Not platforms. Classic me. Let's call it bridges list. Now let's say for bridge in bridges list. Okay, so however many bridges we end up making, let's use this same code every time. Let's say, let's go ahead and make a new group called bridge objects, bridge underscore objects, because we want to keep track of all of the bridges that we make. So every bridge in our bridges list, we want to turn into objects of the bridge class. And so let's keep track of those in a separate list called bridge objects. And bridge objects dot append. And then let's go ahead and append the bridge, capital B, class, but we need an instance of that class. So to do that, like if we were to make one bridge, we would need to use the capital bridge. And so we would say bridge equals capital B bridge, which is calling our class. But then in here, we have to pass in 3 arguments. We have to pass in each X position, Y position, and length. So we could do it this way. We could do bridge, which is now that variable that we're referencing. So maybe I'm using bridge too much. Let's make it crystal clear. Let's say we could reference bridges list item 0. So this is the first bridge, right? But then we want argument 0 as the X position. And then we could call this same thing, and we could pass in the Y position, and then we could pass in the X position, the Y position, and the length as the 2 different arguments. And this would be valid. It would create a total like instance of the class, but there's actually a much easier way to unpack a list, something I just recently learned about and I really like. You use this star character. And so when you use this star character, you're telling Python to unpack the list that it's given in order as the arguments that variable is calling for. So this would be how we do it for 1, but how we're going to do this for every one in that list is we're going to take this bridge variable that we're actually using as the indexer, and we're just going to unpack it. And so as long as we, the programmers, set up our game to where every bridge has the proper 3 arguments, and I'm sorry, it's not the star at the end, it's the star at the beginning. But as long as we, the programmer, set it up to where every bridge has the proper 3 arguments, this is going to take those 3 arguments in order and unpack them. And this is bridge objects, not bridges objects. Okay? And so this is pretty cool. This is going to give us it should give us all of our bridges. So if I go ahead and run this now, let's see what errors we get. Well, we don't get any errors, but they're also not on the screen because one thing that I didn't do, because I'm awesome, is I didn't come down into the draw screen and say for bridge in bridges or anything like that. Bridge in bridges, bridge dot draw. Okay, so we do need some, not capital. So we do need something like this, but you may, if you're a bit of a seasoned Python programmer, you may know that this is not going to work because we haven't created bridges in the outside world. And so we can do it in the outside world if we want, or we can come back into our draw screen and one sec, let's take a quick pause. Okay, sorry about the quick pause. I really had to pee and I absolutely cannot focus when I gotta go. And so to summarize, this is goofy. We didn't need to add this. My brain is just a little scrambled. We didn't do anything wrong. This draw screen function and this draw screen function and creating our instance of the bridge is totally fine. The issue is, if you remember, I did not do the X position based on pixels. I did it on percentage of section width. So it needs to be a number between 0 and 31 so that it draws onto the screen. So let's make this 5 and let's take a look at what we are doing. Okay, and this is pretty cool. You can see the bridge on here and it's 5 long and it's got a gap of essentially 5 spaces off from the left. So if I were to change this to 7, so it's got a gap of 7, let's move it up the screen a little bit, put it at 300, but let's make it 15 long, right? So now, okay, we have a new bridge much longer in the middle of our screen that is a good length, and it's being procedurally created for however long we make the length. And you can see that blue line is what we decided the top of the platform is going to be. And we are going to make a list of these platforms to check for player collision with. So that top line is really important. Now I'm going to come back into the bridge class, and I'm not going to draw the rectangle. I just want to define the rectangle. So now if I run it, we don't have that blue line, but we are still creating the rectangle that we will use for collision detection. Okay, so hopefully that makes sense. And now I'm going to take a bit of a sneaky shortcut here because you guys don't want to watch me go through this picture and tell you where every platform should be and how long it should be and do the math. I'm going to import, I did that ahead of time. I'm going to bring in the length and the positions of everything for level 1, and we're going to get this bridge list in a slightly different way. So let's go back up to the very beginning of our list, and rather than
sort of, rather than go through every platform on this image, do the guess and check. I did that ahead of time. It's going to save us a lot of time. Let me just go ahead and create some variables. So I'm going to create sort of the start and stop y coordinate for every row here that I got ahead of time. If you don't want to grab the code from the GitHub because you're really enjoying the code along, you are going to need to pause and copy these variables down. Okay, this is essentially, I started at the bottom of the screen and worked my way up, which is actually, now that I think about it, I started with the highest numbers and I kind of got progressively smaller. But I used the window height and the slope, as well as the section height and the start of each row, to come up with a good start and stop for where each row ought to be. So the start y coordinate, I took the window height minus 2 section height. So the first platform is going to be essentially 2 times the height of a platform off the ground. And then I sort of went from there and made every row variable. So the row 2 y position is the start y position minus 4 section height. So we kind of have 1, 2, 3, 4 sections before you start row 2. And then from there, I also calculated the tops of each row, and we're going to use these in calculating a lot of stuff when we get to motion. But so these variables are really important. And then in our overall level design, there's quite a few bridges and platforms. So what I did is I made a levels list that is actually going to be a list of dictionaries, where if you have multiple levels, so I want to set this up so that you are able to create your own levels if you want to. So level 0, level 1 basically, is going to be a dictionary where I have an item assigned to the bridges, and it's going to be a list of all the bridges. And then I have another item assigned to the ladders, and it's going to be all of the ladders, okay? And so we're going to draw the ladders together just like we just did for the bridges, but let's go ahead and bring in where all of the bridges need to be, okay? And so be prepared, I'm about to copy it in. These are all of the platforms that are used on that first level. So I have them kind of 3 per line. Again, if you don't want to get the GitHub for some reason, you clearly have internet access, you're on YouTube. I suggest copying these in as well. It doesn't take away from the programming we're about to do. It's just going to save you a lot of time. And all of these platforms are defined based on the row that they're in, how long they're in, how many section widths away from the left edge of the screen they are. And then we have all of them here. So just to go through a couple with you, we start at 1 section width and the starting Y for that first row, and it's 15 long. That is this entire platform that Mario starts on standing, or the plumber. I guess he wasn't called Mario in Donkey Kong originally. But then the next one over from that is 3 long. It's basically 1 slope increment up, and so if we look at the next platform, it starts at 16, right, which is the right edge of the one before it. It's 1 slope increment higher on the screen, and it's 3 long. This took a really long time to design. So if you want to pause here and capture the bridges, and then here get the rest of the bridges, and then if you want to do the same thing for the ladders, we're going to do something very similar for the ladders. And so I'm going to preemptively copy in the ladder coordinates now as well. I suggest you pause, go to the GitHub link in the description, get the ladders and the bridges as well. But so we have these X and Y coordinates based on the rows and the slope and the length, and we're going to use these as well. So this is all the ladders and bridges information for level 1 of the game. I put it in a dictionary so that we can address the actual key bridges and ladders in our draw function. All right, so let's go ahead and go into the draw screen function. I'm assuming you have all those coordinates, and if you don't, I'm assuming you like pain and you want to do guess and check on your own and design it, which is totally fine. But what I am gonna do is come down and set, rather than an empty list, I'm going to say, okay, now I have a ladders list that I want to make that is going to be equal to levels, whatever active level I'm on. So again, I'm making level 1 with you guys, but I want to make this smart enough that if you build more levels, you can just automatically use the same type of logic. So we're going to make that active level variable right here, active
level. And just remember, programming lists start from 0. They don't start from 1. So this first level is actually index 0. And now ladders is equal to levels, active level, ladders. And we're going to do the same thing for bridges. So bridges equals, bridges equals bridges, active level, bridges. One sec. Ladders equals levels, not bridges. My goodness. My brain is a bag of cats. All right, this was a huge project in case you can't tell, so I'm a little fried from building it, and recording it is definitely going to fry me as well. But okay, so what's cool is we can now say, instead of for bridge in bridges list, we can say for bridge in bridges. Okay, so we put it in a list called bridges, and we don't really need this bridges list. We do still want bridge objects because we want to be able to address each of these in a list if we need it. And then we are going to, instead of bridges list, I'll call this platforms or tops. You can call this whatever you want, surfaces. But I'm going to make a list of just those rectangles at the top of each bridge. So we have bridge objects.append bridge unpack that individual bridge. We're going to leave that as is. But we're going to do now platforms.append, and then I'm going to add each bridge object that we just made. I'm going to address the last item in the list. So this will have been whatever we just added the line before. I'm going to append just that .top that we defined as part of the class. So this is going to give me a list called platforms that is going to be just the surfaces. And so I'm cutting basically that entire class down to a list of just the tops so I can easily check for collision with just the piece I care about. And then that's actually the only thing I'm going to return right now out of the drawScreen function is these platforms. Okay, so because I'm returning these platforms, I want to use them in the quote unquote outside world. Come down to my drawScreen function, make a variable I'll call plats. It's my list of platforms. I get that back from the drawScreen function. And what you guys are going to see that is so cool and so powerful of the way we set this up as a class is we wrote that code once. Yes, it was sort of complicated. Yes, there was a lot of drawing involved, but we wrote it once. And now when I boot this up, this entire list of platforms, of bridges, is going to go through and use that same source code. And as long as we define the positions correctly, we are going to get a bridge everywhere on the screen. So let's boot it up. And I got an error, so let's see what I did wrong. Key error bridge. Yeah, so I called it, I think, bridges, right? All right, yeah, silly. So, okay, let's run it now. There we go. And you guys can see this is so cool, right? We have this long platform, then we have this step function of sloped platforms, and then the whole rows are sloped and sloped and sloped. And we go up and we finally have Peach, and we have room at the top for the scores, and we have room over here for the bonus info and all of that stuff. So let's go ahead and take a look now at the next piece, which is the ladders. And again, if you want to know what I got these positions based off of, I used this image, which I just pulled from the internet, and I saw a classic like playthrough, and I figured we could do it all based on this image. So if you see where the platforms are on this image and where the platforms are when we just ran our program, they're almost exactly the same, and I think that is so cool. So now let's go ahead and set up a new class for ladders, okay? The reason I'm doing it in a separate class is because there's gonna be some overlap with what we just did, but ladders and bridges behave pretty differently. You walk on bridges, but you climb up ladders, okay? So let's do class, capital L, ladder. And you're going to see some very similar stuff, and that's a good thing. We're going to do our def _ init _ That is just Python initialization syntax. I think the double underscore is called a dunder, which is funny. We're still going to pass in the X position and the Y position, as well as the total length. But now we're drawing vertically. We're not drawing horizontally anymore. When we define the X position and Y position of a ladder, it is based on an up and down, so the X position doesn't need to change. So let's take self.xpos equal to the XPOS we pass in. And again, we're going to multiply it by section width because everything in the level can be nicely divided into section widths. If you see the list up here, they're all individual characters between 0 and 31 because they're being drawn based on one of those tile positions. Now let's say our self.ypos is equal to just ypos. We're a little bit better on the y positioning because we have to be, because it's not as nicely boxed in as regular tile-based stuff. All right, and now let's do self.length is equal to length. And now instead of calling it top, I'm going to say body. So the part that we're climbing on the ladder, we need to keep track of that in a variable. And so let's go ahead and do self.draw. Just like before. So if we look at the init for the bridge, you're going to notice it's almost identical, but I didn't want to copy it exactly because it's really useful to see this stuff twice. But what we will do now, the draw function is going to be pretty different. And I still want to use PyGame's native drawing tools. After this, we're going to use sprites and we're going to import a lot of images from the actual Donkey Kong game, which again, I've provided in the GitHub link in the assets folder. But for now, I want to use some PyGame native drawing tools. I just think it's really cool to show how you can create a lot of this stuff from scratch. Okay, so let's define the draw function. We're going to put it in that self variable, and we are going to say for I in range, and now it's going to be self.length. So that is kind of where the similarities end. We are still going to need our line width and our ladder color, but what we can do now is we can just say up here our line width is going to be 3 for the ladders. They do not need to be as thick as the platforms, and we'll say our ladder color is going to be equal to, I think for this one I didn't find anything crazy better than PyGame's built-in light blue, so I don't have that like 3-tier RGB like we did for the platforms because PyGame's light blue just looked really good. Okay, so we are going to do some similarities though. We're going to do Y start, or I guess let's say top coord. I don't know why I have so much trouble being consistent. But the top coord, let's make that equal to self.ypos plus, and this is going to get a little funky. I promise. I'm kind of sorry about that. But I did a lot of sort of guessing and checking and experimenting. And what I found was when I pass in a Y coordinate based on where I actually want it to start, it was really useful to have that offset by essentially the section height, but not exactly the section height. The ladders don't work out to where each section of ladder is exactly the height of one of the platforms. So if you look at this screen, you'll see like here, the platform actually goes from the top to the bottom and it has 3 rungs. So I want the length of this ladder to correlate to 3, but the bottom ladder would look kind of different from the top ladder because we need it to start and stop where the rung is actually in the middle of the ladder. So if it seems a little bit confusing, I apologize, but to get the platforms working with the slope and the section height, we have to be a little bit more nimble with the ladders. And so if any of this seems confusing, feel free to drop a comment and ask what we're doing here if you need clarification, or play around with these values and see how that changes your drawing. But so basically the top coordinate for the Y is going to be that ypos that we pass in, plus 0.6 times the section height times I. And so this is why I prefaced it with that. I actually found the ladder works best if we make each of them 0.6 section heights long. And so that makes the bot coord equal to basically the top coord plus 0.6 times section height. Okay, so here we have something similar to what we did with the platforms, but there's this kind of random 0.6 coming out of thin air. Feel free to play around with that, ask your questions like I said. But let's soldier on. So the Y mid, or let's call it now the mid coord, and I guess we used mid coord to mean an X position in platform. We're using it to mean a Y position in ladder. You, the programmer, need to know that. It kind of makes sense when you see how it gets used, but you could definitely change up the labeling if it worked better for you. Okay, so basically the mid coord, the way I calculated it, is just going to be the bot coord minus the start coord, the top coord, and that's going to give you sort of its position divided by 2, but then we need to add that to the y underscore start, the top coord. All right, and I want to talk about what I'm doing here, how I calculated this math, but also how you could simplify it if you know these values are locked in. What this is doing is saying that I want to take the difference between the top and the bottom, divide it by 2, and that's going to say how much I need to move down from the top coord. You could do that. If you are confident in this 0.6, you could make a variable called like I don't know, lad height, and you could say 0.6. You could replace this 0.6 with lad height, excuse me. And then you could replace it here with lad height, and then you could do just lad height over 2. Actually, now that I say that out loud, this is probably the smarter way to do it. I was using a 0.6 to show you guys it's a little bit of a random thing that I kind of just found with guess and check. But if you want to tweak it, if you want to make it taller or smaller, feel free to adjust this value. This is saying however tall we make it, we need the middle to be halfway down from the top coordinate. I hope that makes sense. The x start now, and honestly, I'm going to call it left coord. My notes have it called out as x start and x end. But I'm going to use left and right to try to be consistent. That's right, I'm being consistent on the fly. So x start, the left coordinate, is going to just be the self.x pause. I'm using all these coords, like I said, for the top coord in platforms, because it's a little bit clearer to just see top, bottom, middle, left, right. It's really easy to draw these now that we have these in something named accordingly. So the right coordinate is just going to be the left coord plus section width. And this is nice, even though the height didn't work out perfectly, the ladders are basically exactly one platform wide. So got a little goofy. I don't know if this is how classic Donkey Kong designed their levels. I almost guarantee it wasn't, because I am a self-taught programmer making something in a programming language that did not exist when they made Donkey Kong. All right, but so let's just draw the 3 levels, all right? And it's not going to be too bad, the 3 lines, forgive me. It's going to be screen, and then our ladder color, and then that's going to be the same for all of them. The first ladder is going to go from our left coord, the first line, I don't know why I have so much trouble keeping these straight, left coord, top coord, down to, and the second point on the left line is still going to be the left coord, and now it's just going to be the bot coord, okay? So bottom coordinate, and the width here is going to be our line width variable. And yes, we've called line width twice, but we did it inside of a function inside of a class. And so we can absolutely use the same variable names inside multiple functions, as long as we're not referencing some variable that also is like a global variable. Then the program gets confused. It does not like that. Okay, and so the second line is really easy. We're just going to swap our 2 left coords out for our 2 right coords, and now we have 2 vertical lines for every ladder. The only other thing we have to do to make it look like a ladder is draw the rung going across. So pygame.draw.line, we're going to put it on the screen. We're still going to make it the ladder color, and now the x starting and ending coordinate are going to be the left and the right coordinate that we've already defined, but the y for both is going to be that mid coord that we made. Okay, so we're going from the left middle to the right middle. All right, so those are the start and end points for the line, and then we make line width still. Sorry, I know my image is probably in the bottom right there. I'll scroll up a little. And with your permission, I'd like to go down to this size font so I can fit more on the screen. So these are the 3 lines we have to draw for every ladder, and if we do just this, we're really close. We're drawing the item, but remember, we want to return the body of the ladder, which is what the player can actually collide with to climb. And so similarly to before, I want to do just 1 for every ladder. And so body is going to be, what was that? Body is going to be equal to pygame.rect.rect. Again, we're going to define the rectangle. We're not going to draw the rectangle.
And this is going to be something that starts in what we will say self.xpause. So the x start that we pass in, we could use the left coord because that's not changing, but let's go ahead and be consistent here. And the starting y position is going to be self.ypause minus a section height. And I don't want to confuse you guys too much, but I draw the ladders based on the top left coordinate of where they should actually get drawn. But the player is able to climb up or down a ladder. And so the object that you're colliding with kind of has to be up here. So we don't want a ladder that goes all the way to the top of the platform. That's not what the game looked like. But the hitbox or collision zone of a ladder does need to go one higher. And you might be thinking, well, what about these broken ladders? We have an elegant solution when we come to the broken ladders. We're going to take care of that. But for now, just know that is why I'm going a section height higher. We'll talk about it more when we actually have the player in there and he's climbing up and down ladders. But for now, that is why I'm making it start one section higher than we actually draw it, okay? And so then the end of the body is going to be the x end position minus self x pause y pause. So remember, this is how wide it needs to be. So we could do our final x end minus self dot x pause. This would give us the same value, actually right coordinate, not x end. There I go again. But again, we made it section width. We're pretty confident it's going to stay section width. So the width can be section width. Y end has to be a little bit smarter. How tall to make this total thing has to be a little bit more intelligent. And so what I think we should do is basically take our starting coordinate, which again was self dot y pause minus section height, right? That's where we decide to start this body. So let's take that, let's put it in parentheses here. And then let's say how much longer should it go. Actually, I'm sorry, this is so backwards. We don't need to use that at all for the total height. We just want to say it's lad height times length, so self dot length, but then we need to add in the section height. So this is what was getting me goofy. Total height is going to be our length times how high each ladder is, but then we add in section height because we're making this invisible one section height box above our ladder. So that is going to be the end y coordinate, and then we need to close out that tuple. So we've given it x start, y start, and then width and height. That's all you need to fully define a rectangle. That is a run-on line, but that is okay. And let's go ahead and now just return what we called the body. So for I body, this needs to be indented. There we go. And that should be everything we need. If you're curious, go ahead and draw the body rectangle on the screen and see what we're making. I'm going to skip over that. We defined where all of the ladders need to be. So ladders equals this levels list. Now we're going to take the exact same for bridge and bridges, come right underneath, and say for, maybe I can simplify this and say for lad in ladders, if you guys will allow it. I think that it gets the point across that it is still a ladder. For lad in ladders, or actually I'm going to call it lads on the outside. So let's say for ladder in ladders. Well, this is going to be ladder objects.append instead of bridge. It'll be ladder. And then instead of unpacking bridge, we're going to unpack ladder. Okay, so ladders list. Oh man, I got some work to do on logical naming conventions, I suppose, but I'm working on it, guys. I'm trying. Okay, and so ladder objects.append, it says there's no reference to it, which is weird because it's right there. Let's just soldier on anyways. Now let's go ahead and say we have platforms up here. Let's make a list of climbable ladders. Okay, so I'm going to call this climbers because there's going to be ladders that we draw, these broken ladders that actually are not able to be climbed upon. They're broken ladders. So in classic Donkey Kong, I'm pretty sure you cannot climb up or down any broken ladders. I watched gameplay and they never did. So Climbers are only going to be ladders that we can actually climb up or down. Oh, I called it ladders objects. There we go. That's why. So what we're going to do is we're going to append only the ladders that can be climbed upon to this climbers list. And it's going to come from ladder objects. So ladder objs. But so for ladder in ladders, we're going to add an instance of ladder to the ladder objects list. We are going to unpack our ladder in the same way we unpacked a bridge, which is pretty cool in my opinion. And then we want the climbers to get added to our list. And what's cool is the only ladders that you're able to climb on, as I believe, are greater than 3 tall. So the broken ladders are all like 1 or 2, and then the climbable ones are all 3 in the list that I defined. And so we have this really easy way to only add to this climbers list the actual ones that you're able to climb. And so what we're going to do is if ladder, and I know the length is in item 2, right? So if ladder length 2, just if ladder length, which is in index 2 of ladder, is greater than or equal to 3, then I'm going to add the last ladder that I made. And then instead of dot top now, it's dot body, I believe is what we called it. And then we're going to add just the ladders long enough to get climbed to this climbers list. And then I'm going to pass back the list of the climbable ladders, okay? So I hope I didn't lose anyone there. Basically, we're going to logically make a list of the only ladders you're able to interact with, and we're going to pass that back. And we're going to just weed out right in this if statement, we're going to weed out the ones you can't climb, okay? But now we're passing back a second list. So in addition to passing back the platforms, we also need to pass back the ladders. And that's why I didn't want to use lads inside the function, because I want to use lads outside the function. So not young boys, ladders. That's what it refers to. And just a small thing, let's go ahead and boot this up. And again, if you imported my ladders list, you should have them all drawn already. But what you're going to see is we have a not exactly perfect drawing going on, because actually I think we might have messed up the mid coordinate. But what you also are going to see is they're getting drawn on top of the platforms, and it actually would look better if they were nested into the platforms. So let's go ahead and actually do the 4 ladder list. Let's do the 4 ladder in ladders list above the 4 bridge in bridges list. Okay, so let's go ahead and do it this way. And now if you run it, the ladders are nested behind the platforms, which I think looks really good, but we definitely need to check out why the midline was not drawing in the right spot. Oh, that's interesting. So we did left, we did right, left chord, mid chord, right chord, mid chord. We must have goofed up in defining the mid chord. Let's see. Lad height divided by 2 plus top chord. Is that going to work? Oh, it's because this needs to be lad height divided by 2 times section height. This was just getting essentially a height of 0.3, so we were scooting it down 0.3 pixels. Let's go ahead and check that out. Okay, and I'm much more pleased with that. Now the ladders are actually in the middle of each section of ladder, and I'm pretty stoked about this. I was really, really pumped the first time I put this together. If you pull up that image of classic Donkey Kong over here, zoom out just one click here, and then you pull up our game board, it is awesome to see the overlap here. You can play around with that RGB value if you don't love my like pink versus their like light red, whatever, but the board looks so similar, and we're going to be able to climb all of the ladders that are 3 or greater. So those are the ones that stretch from platform to platform, and we're not going to be able to climb any of the broken ladders just by the way we set those classes up. So I know we're like an hour into this tutorial, and all we've done is essentially drawn a static board. And some of you guys might just want to go out and grab the background of level 1 and say, here's the board, I'm going to start manually defining the platforms. But I'm telling you, as a programmer, this is so much more robust. And now if you want to build additional levels down the line, you totally can really, really easily. Okay? So This is a really good spot. We've defined essentially the items we want to draw onto the screen to sort of define what the level is going to look like. And so I think the best thing to do next will be dive into barrels, right? They have to roll down the entire level, and I think that's going to be a really satisfying problem to solve together. So let's go ahead and take a look at the barrels. Okay, so for the barrels, we're going to take a first look at something that I haven't done a ton of in PyGame, but I know it's super powerful, and so this is something that I really enjoyed implementing for this project. We're going to make this list barrels. It's not really a list, it's a pygame.sprite.group. Okay, so it is going to be a sprite, meaning there's a bunch of useful tools that PyGame has built in to this sprite functionality. All the barrels that we make are going to be a group of the same sprite that we want to be able to use both the PyGame's sprite functionality and treat all of these the same as a group. So it's very similar to creating a class. We're just going to piggyback off of some things that PyGame offers us for sprites. And so you may notice I defined that outside of the while loop because we just need to define that it's going to be a sprite group initially. We don't need to keep redefining that it's going to be a sprite group every time. But let's come up where we're doing our classes now, and let's go ahead and say that this is going to be a class that we will call barrel, just like this. And in here, we're going to say pygame.sprite.sprite. So there's another pillar of object-oriented programming called inheritance, where we're basically going to say in our def init, I'm going to keep saying that is the dunder, double underscore. We are going to pass in an X position and a Y position, right? Just like everything else has had so far when we initially create them. But then these barrels are going to sort of roll on their own and update on their own due to some stuff that we're going to define. But so we first want to say that it's going to inherit pygame.sprite.sprite and then self, comma, nope, just self. Yep, we don't have to pass anything else in. This is saying basically the pygame.sprite.sprite.init, so that's what I forgot, underscore init, and then pass in self. Run pygame sprite sprites initial init function, and we want to take all of the init stuff that returns, so that's like draw, update, some basic stuff available to us. We want to run that right first line in our init function. Now, the barrel has a lot of stuff we haven't looked at yet because the ladders and the platforms are not moving. So we need some new stuff in here. Obviously, we're going to use the X position and Y position that were initially given to sort of define where our barrel needs to be drawn. But there's a lot more stuff going on here than that. So let's go ahead and start by saying that we want our self.image to be equal to pygame.surface. So this needs to be a surface type argument, which is like an image or anything like that. And we're going to import a barrel image pretty soon here. And I'm going to use, I know I said that I wanted to make everything like easily resizable, but this is something where you're going to want to play around with your section width and your section height and figure out what a good size for you is, because for me, the barrels look really good at 50 pixels. I'm not exactly sure how that coordinates with the section width and section height. But so there may be a little guess and check you need on your side here, but I'm going to say that the image initially is going to be a Pygame surface of 50/50, and then I'm going to make self.rect equal to, so we need the rectangle of this barrel so that we can do like hitbox collision detection later, and that's going to be equal to self.image.getRect. So this is a function that is going to get the rectangle of that image, and then self.rect.center. So this is how we're going to use the X position and Y position, is equal to the X pause, Y pause. And again, these barrels are going to act as free agents once they're created. So we just need that X pause and Y pause to be where we want them initially to spawn in, which is going to be right next to Donkey Kong on the top platform. Okay, so self.rect.center is equal to x pause, y pause. And now we need to start looking at things that we're not going to pass into the barrels, but we still need to keep track of in the barrel class. And so for that, we're going to have both self.yChange, which initially will set equal to 0, and then self.xChange. Okay, so these are variables that are going to keep track of the direction and speed at which the barrels need to change. All right, and so xChange will set equal to 1 because every barrel when Donkey Kong initially pushes it off goes to the right, which I'm going to say is going to be direction 1, and then the left will be -1. Okay, and then the classic Donkey Kong image of the barrel rolling is just sort of this one same image with like a dot and a line in it that rotates 4 times. So what we're going to do is we're going to keep track of which one of those 4 positions it's in using a self.pause variable, and we'll initially draw it in position 0. And then every time it rotates at a speed we'll determine, we're going to rotate our image 90 degrees so that we use this position variable 0, 1, 2, 3, 0, 1, 2, 3, and we'll use that variable to essentially keep track of what in the rotation the barrel should be at. Okay, and then so in addition to self.pause, we're going to make an internal variable called self.count that we'll actually use to determine what speed at which we want it to animate. So what speed, it's not really going to change how fast it rolls. That'll be something different for like speed. But then we will essentially keep track of how long it's been in that image so that we can update it and animate it accordingly. And then let's go ahead and make a couple variables that are very specific to Donkey Kong. So if you're not familiar with the classic game, when barrels hit the oil barrel at the bottom, then they have a chance to generate a flaming like sprite. So we want to make a variable called oil collision to keep track of it. And we'll initially make that false. We haven't drawn the oil bin or anything yet, but just kind of knowing that when the barrels get to the bottom of the screen and they hit that oil, there's a chance that they generate a new flame that's going to chase Mario throughout the level. So we'll call that oil collision false. And then we'll keep track of if it's in air or not with a variable called self.falling. And so if it's not making collision with any of those bridges that we already defined, then it is going to be falling, right? That means it's in the air. And then we'll also check if it's colliding with a ladder, because if it is, then there's a chance we want it to be able to fall. Actually, that's something that barrels have the ability to do, is go down ladders. It adds a level of complexity to the level, and that's also partly why we brought in the random module. And so we're going to make a self.bottom of the barrel that we will just call self.rect for now. We're going to update that and just get the bottom piece of the barrel in a second, but for now, to initialize it, I'm just going to set equal to the same thing as self.rect. Okay, and so barrels are pretty cool. In the game, they can roll down these slopes, and they either go to the right or to the left, depending on the slope of the road that they're on. And then they also fall down. They have a chance of going down a ladder, and they have just one simple rect image, which if I go to my assets folder, images, barrels, I have a few barrel PNGs, but that's because 2 of them are standing. So this is obviously huge. It looks pretty good shrunk down to like game size. But you can see it's just a line with a dot. And if you watch the classic playthrough, this thing just kind of rotates the whole time in 4 different sort of images. So let's go ahead and go to the draw function, because it's going to be really simple. All right, define draw.self, and we are going to screen.blit. And then what I'm going to do here, so screen.blit takes a surface argument in the beginning. I'm going to make this kind of a smart surface. So I'm going to say pygame.transform.rotate. And we're going to take the barrel image, which you're going to see it's going to give me a red line, but we're going to define it in just a second here. And I'm going to take that barrel image, and I'm going to rotate it 90 degrees times self.position. So keep in mind, I said this is going to be 0, 1, 2, 3. So this is going to be 90, 180, 270, and then instead of going to 4, it'll go back to 0, which 0 and 360 are the same thing on a circle. Okay? And so the position for this, we're going to take the self.rectangle that we made, so self.rect, and there's this built-in coordinate top left. It's going to give us the x and the y of the top left of that rectangle we defined, and we're going to blit this image onto the screen at a rotation of 90 times self.pause. So let's go ahead and import our first of the images, and let's come up. I'm going to go above all of my like specific level design stuff, and I'm going to import the barrel image up here. The barrel image, we're going to have a lot of images loaded in here, so you're going to get used to me nesting these sort of things together. But we're going to use a pygame.transform.scale on the outside, and then we're going to pygame.image.load on the inside. So you could break this into 2 lines, but we are going to load a ton of images in for this game. It is really going to save us a lot of time putting them on 1 line. It'll also cut down total number of lines of code. So inside pygame.image.load, we need to give it the path where the image lives, and that is going to be assets, images, and then barrels. And then the one that actually spins is going to be just called barrel.png. You'll see what we use 2 and 3 for later. They're the standard barrels that just sit by Donkey Kong the whole time. They look cool, but we're not going to need them for a little while. So for pygame.image.load, you just give it this image directory to load the file in, and that's it for load. But then you need to put comment after load, because what pygame.transform.scale takes is both the image or surface that it's scaling, but then also the X size and Y size to make it. And so for the barrel image, this one, I will go ahead and give it to you in terms of like generic screen size. It's going to be section width times 1.5. That's about the space it takes up on the screen as it's rolling. And then for section width, which is the only other argument we have to give it, it's going to be, so that's the width. And then for the height, it's going to be equal to 2 times a section height. So section height times 2. All right. And so actually, if you wanted to, you could go back down into your barrel class and use these instead of the 50/50 that I kind of hard typed in. To be honest with you, this is such a long tutorial and my brain's already a little fried from making this. I'm going to leave it as is, but you basically could use these instead of that 50/50. Okay, so we are loading in and scaling the barrel image right here, and we are drawing it right here. So that is it for the draw functionality. And now we're still inside the barrel class, and we are going to want to make 2 new functions that I will call define update self. So this is going to be updating its position, and remember, we want that to be something that happens on its own. So we're going to go ahead and update self, and then we're also going to make another function that'll be check fall. Okay, and so I'm going to kind of hand wave at you guys for now and just say let's put pass in here. We're going to come back and we're going to fill these out in just a second, but I want to talk about how to make instances of these barrels fairly similar to how the game is played. Okay, so let's come down into our main game loop. That it's kind of nice. We haven't really done much inside of there just yet. And let's go ahead and set something up to check if it's time to spawn a new barrel or not. So I'm actually going to come up where we have timer.tick and before we have draw screen, and I'm going to do something new. I'm going to say that if barrel count, so this is going to be a variable I'm about to make that's going to keep track of how long it's been since we've spawned a barrel. If that is less than what we decide we want the barrel spawn time to be, so I'm going to make this in terms of that 60 FPS. So if I make it 300, I'm saying I want a new barrel every 5 seconds. If I make it 450, I'm saying I want a new barrel every 7.5 seconds, okay? But barrel count will be how long it's been since the last barrel spawned. Well, if I'm not at my max time, my spawn time yet, all I'm going to do is add 1 to barrel count. But then what I'm going to say is else. So this is when the barrel count reaches the barrel spawn time. I'm going to set barrel count equal to, so barrel count. Ordinarily, if you want it to be the exact same time every time, just set this equal to 0 here because you're going to restart your counting now. What I want to do to make it a little more interesting is say, actually, I'm going to say that barrel count doesn't just go back to 0 every time. So if I make max spawn time between barrels 10 seconds or 8 seconds or 5 seconds, I'm going to take anywhere between 0 and 2 seconds off of that time. So now you won't be able to perfectly time the spacing between barrels. There's going to be a little bit of randomness. You can't just count and go, okay, it's always 5 seconds between barrels. Could be 3 seconds, could be 5 seconds, could be anything in between. But so that's how we'll reset the barrel count. And now I'm going to go ahead and say that the total time remaining, so the barrel, I guess, time, which we're going to use to animate Donkey Kong so it looks like he's grabbing barrels and throwing them, well, that is always just going to be equal to the barrel count minus barrel spawn time, minus barrel spawn time. And the reason we only calculate this every time we come up with this is because Donkey Kong basically has 4 positions. He has grabbing a barrel from the stack, standing there with the barrel, pushing a barrel to his right or left, whatever, and then standing there without a barrel. So those 4 positions are going to be equal to basically a quarter of the time that it takes to spawn a barrel. So we're going to use this variable pretty soon, just bear with me, but understand that's what barrel time is. And then we're going to create an object just called barrel that is going to be an instance of our class, and it's going to be at 270, 270. And again, you might have rescaled your game if it was not exactly the same size as mine. You want it to be pretty much here where my mouse is, right under Peach. And you'll see where I put this in just a second when I boot this thing up. Okay, but basically up here is where the barrels spawn every time. It looks like Donkey Kong is releasing them over there. It was 270, 270 for my window as I have it. If you resize the game, then you just need to sort of guess and check, get this to where it's approximately the same spot that mine is. And then our overall barrels group that we defined up here, barrels.sprite.group, we just have to do barrels.add. And so this is a PyGame function to add an object to a group, but barrels.add that specific barrel. Okay? And so this is pretty much it for spawning new barrels. Let's go ahead and make these variables before I forget. We have barrel count, barrel time, or barrel count and barrel spawn time, as well as barrel time. Let's go ahead and define these up top. And just keep in mind that if you want to change around the functionality of how your game plays, these are good options to do it. So I'm going to make barrel spawn time in a maximum of 360, which at 60 frames per second, counting 1 tick per frame, we are going to say that roughly every 6 seconds. And then initially, I'm actually going to make my initial barrel count. So the first barrel is going to spawn in essentially half the time. So I'm saying 6 seconds, but I want the first barrel to spawn at 3 seconds just to get things running. And then initially, this part doesn't really matter, but I'm going to set barrel time equal to 360. So this one gets reset as soon as we spawn in that first barrel, but I'm just going to do this so that Donkey Kong is in position ready to throw a barrel to start. And then after that, the game is upon us. Okay. So I made those 3 variables. I'm going pretty fast through this, but trust me guys, we are just scratching the surface. This is going to be a long tutorial, so bear with me. And so we're going to do barrels.add a barrel. But then the thing is, we're not calling draw automatically in the init function of barrel like we were for bridge and ladder, because we want to make it a little bit smarter than that. So we're going to go ahead underneath this, like creating new barrels, and we're going to say for barrel in barrels. All right. And now we're using barrel as an indexer to go through barrels. And we're just going to start by saying barrel.draw. Okay. And in a second, we're also going to do barrel.update, and we're going to do barrel.checkFall. But for now, let's just do barrel.draw, and let's boot this up. And hopefully in about 3 seconds, I might have made a mistake, but hopefully in about 3 seconds, we'll get a barrel around here. Yeah, there you go. So that's a first barrel. And right now it's creating a new barrel every 3 to 6 seconds or 4 to 6 seconds. But we're not going to be able to tell because these barrels aren't moving anywhere. So let's go ahead and do another thing here. Let's say that every time we draw, we also want to check for the fall. So barrel.checkFall, that other function that we made earlier, and I just sort of waved my hand and said wait. And rather than doing barrel.update here, which you could, it's totally valid to do it here, I'm actually going to scooch it back one and say barrels.update. And the reason I'm doing that is because I want to touch on something you can do with PyGame Sprite groups, which is call a function that they all have in common and just run it for every single one of them right here. So that's why I'm doing draw here and update here, because it's useful to kind of see that you can call every PyGame Sprite group either individually by object or as a group by the Sprite group, okay? But that's neat. These lines of code are cool, but they're not doing anything, right? We're not messing with the Y change or anything like that. And so what we need to do is we need to fill out those update and check fall functions to be a little bit more useful. But before we do that, we're going to go ahead and say one more thing for barrel in barrels. We're basically going to say that we want to make the collision detection for all of these barrels. We could do it out here, or we could do it in the Sprite class. And so I'm going to show how to do it both ways here. So what we could say is that if our barrel.y change is less than 8, let's say, so some maximum falling speed, and we're not falling, so, and not barrel.falling, then that means we want to go down at basically, we want to increase the y speed. So barrel.y change plus equals 2. So basically what I'm saying is if my y change is not at a maximum speed yet, speed up. But then what I'm going to say also under here is that for I in range length of platforms, right? So all of those, oops, I got the wrong parentheses there. So for all of those platforms we defined when we were drawing the bridges, we could check right here and say for I in range length of plats, if the barrel.bottom, which again we're going to define better in the update function, but for now it's just the overall hitbox. Barrel.bottom.collide rect with whatever plat we just are referencing right now, so plats at I, because we're looping through all of them, well, this means that we're not falling. So basically, barrel.y change can get set equal to 0 because we're not falling. And so barrel.falling equals false. And honestly, this sort of collision detection and putting it all here is absolutely what I did in a lot of my earlier projects. And it made these main game loops really complicated. Some people even have commented politely most of the time that it is what is considered spaghetti code, where essentially you tackle one problem at a time and you just tack code on top of code on top of code and keep making it a little bit more complicated and jumbly. And really the right way to do this is extrapolate out as much as you can. So to put it inside functions, inside classes, so that for barrel and barrels, draw, check if I'm falling, update the whole group. That is all we have to do. So then we need to come up into the barrel class and we need to build some pretty smart update and check fall functionality. And so let's go ahead and start building that out. So that stuff that I just got rid of in the update function, we do want. So we do want to say if self.yChange is less than 8 and not self.falling, then let's go ahead and speed up. Barrel.yChange plus equals 2. And so this is going to be really useful once we start seeing the movement. I know it's kind of hard to like build the code and then see what it does, but that's kind of the nature of building a game, is like you can't really see how it works and then build the code. So just bear with me. And then let's say for I in range length plats. So we are allowed to reference things in the outside world. If we're not updating them, we can still reference them inside here. And we can say if self.bottom.collide rect with the platforms at I. So exactly what we just put in the outside world, but now we're extrapolating it away and saying, wait, this is movement that impacts the barrels. Shouldn't it be inside update the barrels rather than build it all out in our main game loop? Okay, and so if we collide with a platform, then we want to set our y change equal to 0. That means that we are on a platform and we don't want to be changing up and down right now. And then let's go ahead and say that self.falling is also equal to false, okay? And now let's move on from that bit and check if we collide with the drum. So if self.collide oil collision, that's what we called it, oil collision with, if self.collide rect with the oil drum, my goodness, getting ahead of myself. So if our self.rect.collide rect with the oil drum, and I'm going to go ahead and basically just, it's not ideal, but I'm going to do this for now. I'm going to say that the oil drum is equal to pygame.rect.rect. Trust me, this is not where the final rect is going to be, but I'm going to just make it so that we don't get an error as we build this. And I'm going to put it at 1, 1, and I'm going to make it 1 wide and 1 tall, just so we have a rect object to come back and fill in later. But I want to build out how the barrel needs to work right now. So if it collides with the oil drum, we want to check if we have not already collided with it. So that is why we did that self.oil collision variable. We only are going to check this once. Every barrel is going to have one chance to spawn a new fireball. Okay, so if not self.oil collision, we're going to set self.oil collision to true. So now that was your one chance to check if it was time to trigger a fireball or not. And what I'm going to do is I'm going to give it essentially a 1 in 5 chance to spawn a fireball. I don't know if that is exactly straight from Donkey Kong or if I decided that was cool, but we're going to say that if random.randint from 0 to 4, so it can choose 0, 1, 2, 3, or 4. If it's equal to 4, then we are going to set overall this fireball trigger variable equal to true. And so this is something that is going to be in the outside world. Let's go ahead and make it right now. And let's set fireball trigger equal to false in the outside world. And basically we just want, if we collide with the barrel and we have a 1 in 5 chance of setting this fireball trigger equal to true, then we want to trigger, the, what am I trying to say? The new little like flame sprite to pop out of the oil drum. I know I'm getting ahead of ourselves because we're building out how the barrel needs to work and we haven't gotten to this fireball trigger yet. But what we are going to do is pass in fire trig and we are going to return fire trig. Okay, and so instead of calling it fireball trigger, because that's what we're calling it in the outside world, we're going to call it fire trig. We need to come down to where we update the barrels. And actually now I showed you that you can call them all out here, but what we're going to do is say that fireball trigger is equal to barrel.update fireball trigger. All right. Honestly, this is where you could make a case for potentially writing that little check about the oil collision in the outside world, because now we're passing in a variable. It can get changed in there. It's not great practice to use a ton of globals. We could have, rather than pass it in and pass it out, we could have done global fireball trigger right there, and then we would have been able to change a variable from the outside world without passing it in and out. We're going to do it this way. We're going to see if it works. To be honest, I'm going off script a little bit here because I think this is the most optimal way to write this, but we may end up regretting it a little bit. So let's move on from this and let's go now into sort of handling in this update function how to continuously move the barrels. So we've essentially checked for a few things. We've checked to move it up and down. But let's go ahead and build out the check fall function because it's something we can sort of extrapolate out on its own. And we want to check if we should fall down a ladder. So that's what check fall is. We're already handling the are we in air and not on a platform with and not self.falling, which we'll build out a little bit more into the update function. But then let's go ahead and do our check fall, which means can I go down a ladder or not? So let's make this little internal variable already collided, because if it rolls over the ladders for quite a bit of time, right? And so we don't want to check our random, oh, should I fall, every single iteration of it. So let's go ahead and say that already collided equals false. We haven't already hit a ladder. And let's make a little bit of a rectangle that is below our current rectangle. So when you're rolling along a platform as a barrel, the ladder is actually below you. And remember that we made the ladders go a little bit higher, but we are talking about the ladders stopping at the exact same pixel that we want the barrels to roll around at. So it's not a bad idea to check if a rectangle below ourselves is colliding with a climbable ladder. All right, and so if this below rectangle, which we will reference basically as an offshoot of our self.rect. So our initial x position, let's go ahead and say it's the same x position, but then self.rect1, which is our starting y position, plus section height. So one section farther down than our current height. Then we want to go ahead and say that's our starting x position, starting y position. And then we want it to be as wide as our rectangle already was. So the full basically hitbox of the barrel. And let's just make it a section height tall. So this is checking constantly under the barrel to see if we've hit a ladder, and that will be below, which we don't need it to be self.below because we're just using it internal to this one. All right. But now let's say for an individual ladder, for space lad, in our ladders list, so all of the ladders that we have, let's say if our below rectangle dot collide rect with a ladder, okay, and this is where the way we built it out was so smart initially. We have this lads list that is all of just the rectangles of the climbable ladders, so the ones that you can go up or down on. Let's say if below dot collide rect lad and not self.falling. So this, if you are going down a ladder already, we want to trigger self.falling. And then we don't want to check if we're colliding with a ladder if we're already falling. We know you're colliding with a ladder. So we're not falling and not self.check ladder. So this is the variable we'll use to check if we should be colliding with a ladder or not. Well, that means that we have hit a ladder, we weren't already falling, and we didn't already check for that ladder. Let's go ahead and do self.check ladder is equal to true, and then already collided is equal to true. True, there we go. And let's now say if, so similarly to how we spawn in like a somewhat random fire spirit as like RNG, we'll do if random.randint between 0 and 60 is equal to 60, then that's when we want to make the barrel fall. So self.barrel or self.falling will become equal to true. And these are variables that are basically RNG, and they change how the game is played. So just feel free to change your range and just understand what I'm doing when I say if that's equal to 60, I'm saying it has a 1 in 60 chance of falling down a ladder. That's actually fairly high in the course of like you're going to have a lot of barrels on the game, and there's a lot of ladders that you check for collision with. So on average, you're going to get a lot of barrels falling at 0 to 60, but you can make this higher or lower and see how that impacts your game. All right. But so if we hit that, like whatever odds we make it, self.falling is equal to true, self.y change, I'm going to set equal to just a hard-coded 4. So I'm going to say descend the ladder at a speed of 4 pixels per frame. And now one more thing we're going to do in here is basically just keep track of that whole, like, did we collide with something already? And so I'm going to say if not already collided, right? So if that variable never got set equal to true in this little for loop, then that means we didn't collide with any ladders. And so I want to set my self.checkLad function back equal to false. If you think about it, we don't have any good way of resetting self.checkLadder once we've said, oh, I checked for a ladder there. So we need this secondary variable already collided, which will start out being false. And then if we didn't collide with anything in there, we're going to reset self.checkLadder. Okay, so that is the check fall function. It could say check ladder if you wanted to, if you preferred. That's fine. That's how we're going to check if it should descend a ladder. We have to build a pretty complicated way of getting this barrel rolling, though. Otherwise, we're not going to be able to really actually show much progress. So let's come down and let's start talking about how to handle the X change. It's actually the more simple of the two directions because X speed is basically constant for the barrel. It's just left or right based on what row it's on. So let's say if not self.falling, that means that we're not currently descending a ladder, because if we are currently descending a ladder, so I'll put the else right here. If we're descending a ladder, we don't keep changing in the X direction. We're rolling down a ladder, right? Okay. But let's go ahead and check where the rectangle is supposed to be. And if it's, depending on what row it's in, that's going to tell us everything we need to know about going left or right. So we're going to use the self.rect.bottom because that is the actual part of the barrel that tells us what row you're actually on. We don't want to change it going to the left when the top left of a barrel is still above a certain platform and the bottom is not. So let's use self.rect.bottom, which again, we're about to dial in. And let's use that to figure out what row we're on. And so the rows where we want to go to the right, by my numbering convention, are 2, 4, and 6. So we need to figure out if the barrel is on those rows, and if it is, move it to the right. Otherwise, move it to the left. Okay, so building this out is really important to all of our barrels movement. So let's say if self.rect.bottom is less than or equal to the top of row 5. Okay, so rect.bottom is less than or equal to row 5 or row 3 top. And so here's where we're going to start doing things. The reason I put the variable on the right is because we're going to be chaining conditional expressions. So we're saying this rect.bottom being less than row 5 top means that the barrel is somewhere above this point where my mouse currently is. And so anytime it's up here, it's running to the right. But the second condition that we're checking for if it should run to the right is if it's at or below this point, but still above this point. Okay, so we're going to have a lot of different conditions here, but it's going to mean we only have one row that checks if it's going to the right. So first thing was just if it's above row 5, that one's obvious. But then if row 3 top is greater than or equal to self.rect.bottom, and we have to add this in there because it could be on 2 different rows if that was true. So we need to say, or it's also greater than the top of row 4. So that means that we are in that kind of row 3 to 4 transition zone. And we're going to have one more that's going to look just like this. So copy that over. And then this one is going to need to be less than or equal to row 1 top. But also greater than or equal to row 2 top. And I know that's a lot of chained expressions, but what we're doing here is basically checking, is it on row 2, is it on row 4, or is it on row 6? And if any of those if statements are true, then we want to set self.xChange equal to 3. So this is x speed. Basically, I'm saying I want to go to the right at a pace of 3, okay? But then else, I'm going to say self.xChange is equal to -3, all right? So I want to roll to the left at a speed of -3. And I don't have to do a bunch of complicated if statements because the only 2 positions a barrel can be on are on a row where it rolls to the right or on a row where it rolls to the left, or it could be descending vertically on a ladder, which we already handled with the if not self.falling, okay? So that is xChange, and I know, self.xChange equals 0, I forgot to put that in there, and I know that is a bunch of gobbledygook, and actually I'm scrolled to the right. I was like, I don't know where the def went. Okay, getting a little goofy here, but we're doing well. Self.xChange is equal to 0. And then let's go ahead and start taking a look at some of the Y directional stuff. So before I forget it, because we aren't actually updating anything yet, the way we're going to do that is self.rect.move IP. Okay, so this is going to move the rectangle based on our X change and Y change directions. So we're going to say self.xChange, self.y change, and that is how much we want to move the rectangle by. Okay, but there's more work to be done here. We want to also get rid of barrels in kind of a smart way. If they've finished rolling down the platform and they've made it off the screen, we don't want to just keep adding endless barrels to this list of barrels and then we're updating their position off screen, way below screen. It's a waste of processing power. So let's go ahead and say if self.xChange, sorry, not self.xChange, self.rect.top becomes greater than the total screen height, right? So the top of our rectangle becomes greater than the screen height. Then we're going to use a nice Python Sprite class built-in function, which is self.kill, okay? And it sounds very violent. It just gets rid of this item from the Sprite class. It's kind of nice. We're going to piggyback off of this when we get the hammer implemented and the player has the ability to squash a barrel with the hammer. We're going to use self.kill then as well. It removes it from the class. And so if a barrel has rolled all the way off the screen, we're going to use that as another opportunity for self.kill. Okay, and it's just going to get rid of it so that our class is only barrels that are actively in play. Now, let's go ahead and use the self.count variable that we made to sort of handle animating, like I said. So if self.count is less than 15, which means a quarter of a second, the way we're doing this once per frame, right? So a quarter of a second is how fast I want to animate. Well, I'm going to say if it's less than 15, let's just add 1 to the count, okay? But else, so it equals 15, let's go ahead and say self.count is equal to 0. And now, in an ideal world, we would just make it go to the right, or we would increment from position 0 to position 1 to position 2 to position 3. But I want to be smart enough that this works for rolling to the left and rolling to the right. So we need to add another conditional statement that says if self.xChange is greater than 0, which means I'm rolling to the right. Then we want to say, okay, it's going to the right. So now if self.pause is less than 3, so remember 0, 1, 2, 3, those are the possible positions. We're just going to add 1 to position, self.pause plus equals 1. But we need an else to reset it because we don't want to go from 3 to 4. We want to go from 3 to 0. Okay? But that was if we're rolling to the right. So we need an else on that if self.xChange greater than 0. And we're basically going to copy this, but we're going to append it, kind of change it to where if it's greater than 0, we want to go backwards. We want to subtract 1. But otherwise, then we need to go to 3. So I hope this is not too goofy for you guys. This is basically checking if we're going right, roll the image to the right. Because remember, self.draw is a 90-degree transform of our one image over and over. But then when we go left, we kind of want to do this same thing in reverse. And rather than do a bunch of goofy stuff in our define draw function, I'm going to keep draw really simple. And I'm going to use this update function to handle all of the changes to the player's, to the barrel's movement. Okay? And hopefully, this is a lot of stuff. So there's a high probability we goofed something out. But as I have been promising, let's go ahead and define the self.bottom rectangle a little bit better as pygame.rect.rect. And then we're going to use the self.rect 0, so the left coordinate. And then we're going to use the self.rect.bottom, which is the built-in bottom coordinate for a Pygame rectangle. And then we're going to make it self.rect 2, which is the width of our full-blown rectangle. And then it's going to be section height. So I am basically saying I want the bottom of the rectangle to actually be based on the bottom part of my rectangle. So it's similar to self.below, which we made in check fall, but I'm going to update it up here just to be a little bit easier. And that's what we're using to check whether we need to go left or right. Okay, so my goodness, we put a lot of stuff into this function, but it's because once we have this built properly, we can set it and forget it. We have these few lines of code checking if it's time to spawn a new barrel in, create a new barrel. Okay, and just these lines of code hopefully will handle making new barrels and then having them run down the screen for us. So let's see, we built a lot of stuff, but you can see it is rolling to the right, and I just think that is so cool. It did fall and it fell off the screen to the right, so I think we need to get a little bit better checking if it's time to fall. And I also don't like that it is, actually it didn't switch back to the left, which is interesting here. And it looks like its collision was imperfect with the second row. And it's not falling down. So we're going to keep taking a look at this, but I just think it is so cool how it comes in and it glides to the right already. I do think we want to draw the barrels after we draw the screen. And so I think that maybe we need to move draw screen up above it, and that'll help with the visual of having it roll behind the ladder. But now we need to figure out why our collision detection is just a little bit off. It did fall at what felt like the right time, and it fell at a good speed, but it never shifted back to going to the left until it was a little bit too late to course correct. So let's just take a look one more time at what was going on there and see if we can cook up a good fix. Okay. I am pretty sure the issue is just we made that bottom rectangle really tall, and I think I goofed by using section height here. I think this is sort of like the top of the platform. We just want it to be like a 3 width rectangle. I don't know if that's going to be all we have to do to fix it, but my first hunch says the animation looked a little goofy with the bottom and it wasn't falling down. So like, yeah, there you can see the barrel. Okay, that looks so much better. The barrel should actually go down every time it rolls onto a new platform. So it should get this little movement because we have that every time it's not colliding with a platform, move downward until it is colliding with a platform. And so you can see if you were timing this with a stopwatch, we're getting a barrel every like 3 to 5 seconds. So it's not perfect in the sense that it's not like every 5 seconds and the player could just time it up. It's a little bit of RNG, and it looks so cool. And honestly, these barrels are acting, like I said, as individual agents. It does look like it doesn't start rolling to the left at the right time at the bottom. So let's go ahead and check out how we can fix that. But other than that, I'm really happy with the barrels. It's looking cool. We have the built-in barrel rectangles as well. So it's going to be really easy for collision detection when the time comes. Other than the fact that they're not currently rolling back to the left on the bottom row, I'm super pleased with this. So let's just finish that piece off. And my gut says just from watching it that the issue is probably in this equal sign. I'm not sure why it works so well for row 3 and it doesn't work for row 1, but it looks like the barrels are coming to rest perfectly on top of the point that's row 1 top. And so I think, yeah, like I would have thought it'd be the same issue here that we're having below, but I guess we're not, because it changes direction and the animation looks great. If you want it to spin a little faster or slower, you can just change that 15 that we put in, but it's rotating, and it's rotating in different directions if you monitor them closely every time it gets to a new direction. And so, yeah, it looks like they're shifting really well from left to right now. And so that's really cool. If you guys feel like we're building a lot of stuff without putting any player controls in, that's because we want to build the game and then almost drop the player in as a sprite inside of the world that we're building. That's the order that I'm going in. And so that way, once we get to the player, we can focus on the player, building in the player lives, collisions, resetting, and scoring. Because if you had a player and you didn't have a world for the player to interact in, it can be really tough to test that functionality that you've built. So I'm super pumped about this barrel class. I think it's really cool. I think it's doing a ton of stuff, and I think it's working really well. why don't we draw in a little more context for our game? So this isn't going to take very long. It's going to be sort of some extras that we draw onto the screen. So let's go to our draw screen and let's make a draw extras function where we're going to start building in the additional stuff, because like Donkey Kong and the oil barrel and the stationary barrels next to Donkey Kong are all sort of the extras that make the game like really cool and really satisfying. And so I think what's kind of important is getting those on the screen so the game feels like it has a little bit of context. All right, so let's come up to define draw screen, and let's also define draw extras. Okay, so extras, just like that. And this is where I'm going to put lives, levels, bonus, text, etc. in here. So this is where we'll draw some of that text. That's going to require some special formatting, but that's okay. And then we're also going to draw peach. So just to be clear about everything that we're going to draw, then we're also going to actually get our oil drum back from this function. So I'm going to call the oil drum an extra. So we'll get oil drum from extras, and I can get rid of this now. And we are going to draw the oil drum, and then we are going to draw our barrels, our stationary barrels. So draw stationary barrels, and then we are going to draw Donkey Kong. And those are going to be all the things that we are going to draw in our draw extras function. All right. So let's go ahead. Why don't we start by drawing the oil drum? We already kind of defined this one. And I'm going to sort of extrapolate out. These are going to be sort of simple functions on their own. But rather than draw extras getting all gobbled up, I'm going to draw like Donkey Kong in its own function. I'm going to draw the oil in its own function. I'm going to draw these barrels in their own function. So I'm going to draw barrels, and I'm going to draw Kong. I think because Peach is not doing anything particularly interesting, we can draw her right in here. And because the rest is just text, we can draw those right in here. And then we're just going to need to make sure we return the oil out of here. Okay, so we have these three functions that I just sort of committed myself to defining. So let's go ahead and throw them all down here. Define draw oil, define draw barrels, and define draw Kong. And sort of the way to get around defining a function that you're not quite ready to put stuff in is just throw pass in there until you are ready to fill them in. And that's enough code that your code at least won't error out, unless it's supposed to return something, which draw oil is. So let's go ahead and start at draw oil. Most of what we're going to draw, Donkey Kong, Peach, the barrels, everything like that, we're importing images for. The oil barrel, I don't know why I thought this would be so fun, but the oil barrel is just like a few basic objects, right? It's a rectangle for the main body, two thin rectangles for the top and bottom lip, some light blue rectangles for like the details and shading, the word oil, and then like 4 red dots. And I'm just like, I was sitting there saying what these shapes were in my head, and I was like, man, I have got to just like draw the oil barrel myself, because PyGame has really easy tools for drawing all of these things. And so let's go ahead and take a look at how I did that. If you don't like this, you can go out and you can get the image for an oil barrel. It's not that hard. They have them free online for the Donkey Kong sprites. But I really want to do it this way. So I'm going to pull in an X coord and a Y coord, which sort of guess and check. I was able to track down that like 4 times the section width and the window height minus 4.5 times the section height is sort of the perfect like top left coordinate for this oil barrel, okay? So I'm going to use that as my X and Y coordinate. And I know this is a minor detail in the game and you guys want to get back to the game play and functionality. So I'm going to go pretty quick through these shapes, okay? But the actual oil body that we're going to return is going to be a big rectangle based on those coordinates. So pygame.draw.rect, and it's just going to get put on the screen. We're just going to use PyGame's default blue. And then the X and Y coordinates are going to be X coord and Y coord. That's kind of how I picked them. And then total width for this thing, 2 times section width made it look pretty good. Again, I'm not trying to tell you guys how to live your life, so if you want to play around with these heights or these widths or hard code pixel values in here or anything else like that, go for it. But 2.5 section height, 2 times section width looked pretty good for me. And then I just want it to be a solid rectangle by default. And that oil value is what we need to return because that's the main body that I want to use to check if barrels are colliding with it. Okay, so that's it for oil. Now let's draw these details in here because I know I got kind of creative and artsy as a programmer, but everything that goes on that main oil body can be drawn with some pretty easy PyGame functionality. So let's make another blue rectangle, draw it on the screen. This time we're going to scooch it back to the left just a little. So x coord minus 1/10 of section width, right? And this is the top lip to be clear. And now it's going to be y coordinate. And then that's going to be it. We're going to draw it at the same top position. And then we want it to be 2.2 times section width so that it has the same lip to the left and to the right. And then total height, I just want it to be 2.2 times section height. Okay, so this is the top lip of the barrel. I'm going to copy that whole rectangle down here, and we're going to append it slightly so that, amend it. So that rather than the top lip, it's the bottom lip. And to do that, we just need it to be y coord plus 2.3 times section height. So thinking about this kind of logically, we made the entire barrel 2.5 tall. We want this to be a top and a bottom lip. And so all we have to change is where to start it for that second lip. All right. And now let's talk about the 3 light blue lines that are kind of the details. The first one is pretty clearly a vertical line, pygame.draw.rect. We're going to put it on the screen. And now instead of blue, we're going to use light blue. And for an X and Y start position for the first light blue, we're going to use our X coord and we're going to come a little bit inside it to the right. So 0.1 times section width, and that's our X starting coordinate. And then our Y starting coordinate, we are going to make our Y coord. And then sort of similarly, just scoot it inside a little bit. So plus 0.2 times section height. That's going to be our Y starting coordinate for the left vertical light blue line on the oil barrel. Let's make it pretty thin. So 0.2 times section width is the total width of this rectangle. And then I'm going to let it kind of auto reformat some stuff here because it doesn't like not having spaces, blah, blah, blah. And then it also is telling me I've run on lines, but man, this program is going to have other issues other than run on lines. So let's move on. And then the height for this one, we actually want to be almost the whole height of the barrel. So we're going to do 2 times section height. And it's going to be this thin vertical line that goes up and down the left edge of the barrel, similar to the one they have built in. And I don't know why I thought this was also cool. Maybe because it's sort of similar to like the pixel art that original game designers had to come up with, like sit down and design the pixel diagrams of what RGB values to give them. And it just felt a little bit more like doing it from scratch. We are absolutely going to be pulling in images for almost everything else. So don't worry, you're not going to be watching me try to draw Donkey Kong from scratch as well using PyGame. That would be crazy. Okay, but so now let's do the 2 quick horizontal ones. They're going to start at the X coordinate. I got to put these inside square brackets. The top one is going to start all the way at the left of the barrel, and it's going to be close to the top, but not the top. It'll be Y coord, and then half of the section height down. And then we're going to make it 2 times the section width, so the full width of the barrel. And then pretty thin, so 0.2 times section height. And then this is the top thin light blue line, so let's go ahead and copy it. Okay, well, it took some liberties on giving me new lines when I copied, but that's okay. And we're going to keep everything the same here, except the Y coordinate is getting moved down from 0.5 to 1.7. And now we have the main body of the oil barrel, the top and bottom lips, the vertical left line, and then the 2 horizontal light blue lines. We need the word oil, and we need our little red dots going across the body of it. So next, let's do screen.blit, and let's go ahead and make a font.render. And we haven't defined font yet, so it's giving me a red squiggly line. We're going to go do that in just a second here. So kind of cheating here, but I'm going to call this font2.render because I use regular font, font1 a lot of other places, and this is going to be font2.render because it's basically the only time we use a font this size. But the text on the drum just says oil. We're going to make anti-alias true, which is just a variable that sort of smooths out the edges. And then we're going to make it light blue color. And then the X and Y coordinate for oil is going to be X coord plus 0.4 times the section width. And then we are going to make the Y coord plus 0.7 times section height. And now that is all we have to give the text, but we have not made font or font2. So let's come up here. I don't know. Yeah, that's where return needs to be. Let's come up to the beginning, really early actually, where we define the screen. Let's make font and font2 up here. These are things that you can initialize pretty darn early in your game, just so that you can reference them later when you're ready to use them. And I use this in most of my games, so fans of the channel will be familiar with free sans bold.ttf. It comes installed with Python and PyGame, and Windows and Mac, I think, support free sans bold.ttf. So I made it this so that you did not have to import a font file as well. Just one little thing that hopefully can speed things up for you. And then I'm going to make the main font pretty big, size 50, which I just did above, and then the secondary font size 30. It's just kind of an easy way to define a font that you are able to use two different sizes for. So this main font will be like what we track the score and the bonus and the lives and all that with. And then this font 2 is going to be for the oil. Okay. So let's come back to the oil. We should be all set here now. And let's go ahead. Last thing I want to do is I want to make a little for loop and draw those 4 red dots on the oil jug. I know I'm doing some sort of like unnecessary extras versus like importing an image, but I just think this is a ton of fun, and hopefully you do too. So for I in range 4, let's go ahead and pygame.draw.circle now. Let's put it on the screen, and they're just plain red dots. So let's use red, and the X and Y center position for those dots are going to be X coord plus 0.5 times section width to get it away from the left edge a little bit, but then plus, and now we're going to use I times, and I want to scooch them 0.4 each times section width. So we're coming a half of the section width away from the left edge of our total oil barrel, which is too wide. And then we're going to have it at 0.5, 0.9, 1.3, and 1.7. Okay, I thought this looked really cool when I was testing it. If you don't, feel free to play around with it. And then the Y coord for these is going to be the same for all of them. It's just going to be 2.1 times the section height. And then the last thing you have to give a circle is a radius. So I am going to make it radius 3 so that they're just nice little red dots on the oil body. Okay. And now let's go ahead and boot this up. There's a lot of procedurally drawing stuff, and I probably got I did no file free sand bold. Yeah, there's no file free sand bold. This is sans bold, apologies. And let's try that again. Okay, so there's our little oil drum. I don't know why. I think it is so cool to just unnecessarily do that little extra step and draw that in there. You could just go screen.blit an oil drum and then get the rectangle associated with that image. You would be fine. In fact, you might be smarter than me. I just thought this was fun. So let's see. One more thing that actually I think we should do is draw the flames on top. Okay. So let's go ahead and say if some new variable that we're going to make called counter is less than 15 or counter is less than 45 and greater then 30. So I'm going to make a new variable. I use this in a lot of my games, a counter that is going to keep track of every minute. And so it's going to go, every second. And so it's going to go 60 times a second and then reset itself. So what I'm saying is I want this counter to go every 15 seconds for animating my flames. But I'm going to go ahead and screen.blit a flames image on the top, right? So the thing is it's burning. So we'll say flames image, and we'll put it at the X coordinate as well as the Y coordinate minus section height. So we haven't made flames image yet, and we haven't made counter. So I am waving my hand at you a little bit right now, but we are about to do that in the next step. So let's go ahead and say otherwise, we are going to blit the same image, but this time we're going to do pygame.transform and a new one, .flip our flames image. And when you flip something, you need to give it, do you want to flip it in the X direction and do you want to flip it in the Y direction as your two arguments? So we're going to flip the same flames image 2 times a second so that it looks like flickering flames. I think that's kind of cool. In the assets images folder, I called this image fire. It's just this pixelated flames. And so by flipping it 4 times a second, basically, we're going to get this cool like crackling fire effect. All right. So obviously we have to go up to where we loaded in our, here it is, barrel image, and now we're going to import a flames image as we called it. And I'm going to steal most of this line because we're going to scale it differently, and we don't need to go into the barrel image, but most of it's actually the same. So it's going to be instead of barrels and then barrel PNG, it's just assets images, and this one was fire PNG. I have PNG twice now. And instead of being 1.5 by 2 height, this one we have to update the height slightly. It is actually just going to be 1 times section height, which is why we scooted it 1 times section height above the top of the oil barrel. And then the section width for this one, we just want it to be 2, not 1.5. And let's go ahead and make our counter variable as well. So counter equals 0 initially. And we want that to, like I said, we want that to be a 1 second counter. There are a whole bunch of reasons you might want to know every time a second passes in your game. So go down to your timer.fps, basically your timer.tick, and just do an if counter less than 60, then counter plus equals 1, and then do an else counter equals 0. So just like that, now you have this value that is going to reset every second. It's really easy, really simple. Let's go ahead and run this and see if we get a flickering flame on top of an oil bin. Yeah, so I don't know. I think that's really cool. It is kind of a minor thing, but it's important to the game of Mario. It actually is where like the little flame sprites that chase you come from. And so it is an important piece of the game, and I'm pretty stoked we got that down. All right, let's move on to draw barrels. This is going to be one of the easiest ones because it is just 4 stationary barrels, but I still think it's useful to sort of pull it out of the main game loop and do that separately. So I'm going to collapse down draw oil for the time being. I think we are all set there. I'm actually also going to collapse down the levels list because it's huge, and this needs to get a little bit easier to read for me to keep working on it with you guys. All right, so what we need are the 2 images of the barrels on their side. So if you look back at the level, you can kind of see that they are slightly different. They might just be the same image flipped, but actually I think one is a little bit wider on one side and the other is not. So I grabbed these 2 images of the barrel on their side. Again, it is, those might be identical. Okay, well, maybe we should just bring in one. Let's just do one. I'm deciding on the fly. We're just going to use the same image for all of these. Okay, so barrel on its side is going to be equal to the same PyGame transform scale. And let's go ahead and PyGame image load images. And then for instead of fire, we are now going to go back into the barrels and load in the barrel 2. Barrel 2 PNG. I'm going to leave barrel 3 alone. I never want to see it again in my entire life. Okay, So the barrel on its side is going to be section width times 2 wide and section height times 2.5 tall. And if that seems a little bit misleading, I apologize. But it is actually because we are going to rotate them. The images that I have when I pulled them off the sprite sheet were laying on their side. So we're going to come down into the draw barrels function, and it's just going to be 4 easy lines of code. Again, this is one I did a little bit manual. It's not quite as smart as maybe some of the automatic resizing stuff. But honestly, if you need to resize your window, scoot these around till they look good. They don't really do anything functional in the game. They just look cool. So pygame.transform.rotate. And then we want the barrel side. And then we want to rotate it 90 degrees. So that is the second thing you give transform.rotate. And then we are blitting it on the screen, which means we need to tell it where. And so I'm going to put it at section width times 1.2, and then 5.4 times section height to get it down from the top of the screen. And I'm going to copy this one line, and rather than some for loop, it's only 4 lines of code, and they are all sort of looping back and forth between 1.2, 2.5, 5.4, and 7.7. So we need a 1.2 at 7.7. We need a 2.5 at, not 5.2, just 2.5 at 7.7. We need a 2.5 at 5.4 and a 1.2 at 5.4. This is going to give us a little square of 4 barrels on their side. So let's go ahead and run this. And you can see we just have the standard Donkey Kong barrels up on the top left in a good position. Obviously, the barrels themselves, when they roll, spawn just out of thin air. And the reason they do that is we have not drawn Donkey Kong yet. Okay, so drawing Kong is pretty easy. We're going to use some stuff that we set up a while ago, even if you may not remember what it was for. We are going to use the sort of barrel time stuff to figure out what phase we should be in. So we're going to make this internal variable to this function. It's going to be equal to barrel time divided by 4. So each phase of time that Donkey Kong's going to spend in each position is going to be equal to 1/4 of the overall barrel time. Excuse me. All right. And so we are going to say if barrel spawn time, which is how long has elapsed, minus barrel count. So this is actually how much time has passed since we last reset. And if that's greater than 3 times phase time, then we need to be in the kind of like the last image. So dk underscore image is equal to dk2. So 0, 1, 2, right? I think we can reuse the one where he's in the middle because it's the same position both times. But let's take a look and see if, I'm not sure why in my notes I put 2 and then 1 and then 3 and then flip of 1, but I think we're going to be fine. Just give me 1 second here to go through all the different phases. So elif, and then same thing if it is greater than 2. This might be a good candidate for a case switch functionality. That's a little bit of neat Python I've been learning about. But honestly, I'm going to throw that red herring at you that it might be a good candidate for case switching, and then I am going to not do it. So case switching, if you're familiar with other programming languages, you basically can set a condition up and iterate through a series of numbers. So in this case, like 3 times, 2 times, 1 times else. But we're not going to do that. We are going to use ifs and elifs because it's really easy to read and understand. And basically all I'm saying here is, okay, I have these different things I want to draw it on. And so thinking through the phases, we have standing there with no barrel, reaching into the barrel stack, standing there with a barrel, pushing a barrel off to the side, and then it cycles. Those are the 4 images classic Donkey Kong does. And so to look at DK1 here, he's grabbing a barrel, he's standing there with no barrel, he's standing there with a barrel, and then if we flip DK1, he's pushing a barrel off to the other side. Okay, so let's go ahead and do bringing in those images. It's kind of hard. I know it's kind of hard to visualize these things until we get them loaded in. So let's go back to our image loading. We are going to have 3 new imports where we are going to transform.scale. So you can grab any of these that you want. We're going to rename them. We called them DK1, 2, and 3 because that is how I named them in the folder. So now it's going to be PyGame.image or /images/DK, and then just make sure you get this order right if you're using my images. And these monkeys are big, so we're going to go for 5 and 5, and then let's go ahead and copy this, and let's go ahead and do DK2 and DK3. 2, and then 3. Okay. And so I want to come back into my draw Kong now that I've actually loaded in those images and I can do something with them. And let's go ahead and say, so I think if I remember correctly, 2 is standing there with no barrel. 1 is grabbing a barrel from the stack. 3 is standing there with a barrel. And then we need to flip 1 and draw our image for a barrel on the screen. So that's why else is not filled in yet, because then DK underscore image is going to equal pygame.transform.flip, and we are going to flip it, we're going to flip DK1, and we're going to flip it in the X direction and not the Y direction. Okay, but then we have to do one special thing for position 4 because it's pushing a barrel off to the side, remember? And we are about to release it. So we are going to put the barrel image in Donkey Kong's hand. I'm just getting around loading a 4th image of him holding a barrel because we already have the image of the barrel. And remember, we put that new barrel at 270, 270 every time we create it, I think. And so now what we can do outside of the if is just screen.blit our DK image variable we've been using in here. And a good position for the image is 3.5 times section width. So it's just to the right of those static barrels. And then a good Y position has just been row 6Y minus 5.5 times section height. So this was a little bit of playing around with what looked good. He's on the 6th row, but he's 5 tall. You could use row 6 top or row 6Y. It doesn't matter. You just have to tweak this a little bit if you change it. Okay. But I'm hoping if we set everything up correctly, Donkey Kong is going to kind of coordinate pretty well now with releasing the barrels. So actually, I think we need to move. Yeah, okay. It's a 50 pixel square, and we need to draw the barrel in the top left of it. So I think more like 250, 250 or 245, 245 would look seamless. But let's run this. All right, so we start out with Donkey Kong holding a barrel. He reaches over here. He releases it way too low. Let's play around with that in just a second. And now he's not moving at all. Okay, so I think we're close. Oh, it's because this shouldn't have become 270, 270. That should be in the draw Kong function that goes 250, 250. So let's come up here, 250, 250. That should look good for the first one, but then we need to figure out why it didn't reset properly for the second one. So he reaches over and he releases a barrel. That looks really good. The problem now is he doesn't reset properly. So we need to take a look at how we're resetting those spawn times when we release a barrel. So let's come back down to our barrel releasing and see what I did silly. I'm not surprised I messed something up. Okay, so as long as barrel count is less than spawn time, just count up by 1. That is pretty straightforward. I don't think we messed that up. But then we'll set our barrel count equal to 0 to 120. We'll recalculate barrel time, which is the total spawn time minus the barrel count. We'll make a new barrel. That part is working. And then we'll add a barrel to it. So I'm not sure what could be going wrong there because I think draw Kong, unless we're never recalculating that phase, but we are. We recalculate every time. Spawn time minus barrel count is greater than 3 times phase time. And he just sort of goes back to DK2. So I'm a big fan of troubleshooting. So let's go ahead and print phase time in our console window. And maybe while we're running this, that'll give us a clue. Let's do phase time. And then let's also print out barrel count. So hopefully that'll tell us that the barrel count is still going. And then let's print out, yeah, barrel time. I guess we'll see those update only just once every time. But so, okay, 253 cents. Oh, it goes pretty negative. That's interesting. 287. No, I guess that's okay. All right, let's take a pause and think about what is happening here, why Donkey Kong won't animate. Yeah, so the negative signs were a good warning sign. We want the barrel time to be the total amount between the max spawn time and the count, so whatever initial value we just came up with, and it needs to be spawn time minus barrel count, not barrel count minus spawn time. So I do think that'll fix it, hopefully, and our animation works now. So he goes to the right, and it actually occurs to me that the area of my screen I'm recording, you probably weren't able to see, but in the terminal window down here, I was printing out those values and I was getting negatives. So, I mean, if you were following line by line, you probably were also. But now you can see we get this kind of 4-panel Donkey Kong where it does look like he's grabbing barrels from the side, standing in the middle, and then throwing them off to the right. And again, Donkey Kong is not really doing anything in this game. The barrels are actually the challenge. But it is still kind of cool to get him animated because it wouldn't really be fun playing against just barrels rolling at you. So having the animated monkey is actually a really cool enhancement here. And that is going to finish it for Draw Kong. For Draw Extras, I think we can probably draw Peach right now, and I'm going to come back for the text because that's kind of boring. Not that it's boring, but until we're ready to do scoring and life detection and bonus stuff, there's not really a big benefit to it. So let's go ahead and go into Draw Extras and figure out what we're going to do for Peach. And actually, preemptively, let's just go up to where we load in images, and let's load in the 2 Peach images. So she just kind of stands there, classic damsel in distress. I think that's maybe not how you would build a game today, just a standing damsel in distress. You'd probably want her to be a little more proactive in her rescue, but that's okay. We're going to do, so pygame.image.load. For some reason, I didn't copy it from the above lines. We are going to load in assets /images and then /peach and then / and I just have peach1 PNG and peach2 PNG. So load in peach1 into your peach1 variable. And for width and height for her, it's 2 times section width and 3 times section height is just a good size for the images that I have. So if you're using the same ones as me, just use those sizes, but feel free to play around with scaling, no problem at all. And just change Peach 2 to Peach 2, and we are done with Peach 1 and Peach 2. And so what we want to do is we want to come down into Draw Extras, and even though I am a big fan of extrapolating things out into sub-functions underneath functions, Peach is just, she's really simple. So what we're going to do here is we're going to say if barrel count, so how long it's been, is less than barrel spawn time divided by 2. So basically I'm saying per barrel, let's just animate Peach once because she's just kind of standing on the top platform, like looking helpless in both images. So we're going to do Peach 1, and a good position for it is 10 times section width, and then a good height for it is the row 6Y, and then -6 times section height. So this is just going to move her up to basically standing on those special platforms just for her. And then basically we're going to say, okay, that's roughly half the time. And we will just say else. So otherwise, let's go ahead and screen.blit Peach 2 onto the screen in the same position. All right. And so it's a really minor enhancement. It didn't take us very long to do, but now we made an error. Argument 1 must be surface, not tuple. All right, I'm sure I forgot to close parentheses in the right spot or something. So let's go to line 42. Peach 1 transform.scale. This closes here. image.load. Yes, okay, the scaling needs to be in a tuple. And so this, you need to just double check your open and close parentheses. And so I did not have the X and Y scaling in parentheses. So that is a reason that I should have copied it. What do you know? And I still got an error because of line 42. So I must not have fixed everything. Oh, this is embarrassing. This is like the 10th image that I've loaded in. And that one closes what? That one. And then that closes that. Yeah, so, okay, argument 1 must be a surface, not a tuple. Yeah, this is a surface. Oh, I don't know why I have a close parentheses here. Maybe? No, undo. This is an embarrassing bit of troubleshooting. I've just loaded in like 12 photos. Okay, I'm trying to look really closely here. I think I have an extra parentheses here and an extra one at the end. And I think that's what the problem was. Let's see. Oh, thank goodness. Oh, what an embarrassing moment for Pete. Okay, but you can kind of see, yeah, the two positions that like classic Peach has is just like hands forward, hips back, and then hips forward, hands back. And so she just oscillates between those every time we throw the barrel. But it does give the game a little more sense of life, I think, and energy, let's say. So, okay, we will put the text here later when we get to scoring and things like that, absolutely. But for now, let's go ahead and put a post-it in Draw Extras. And I think maybe let's take a look at the next sprite that you interact with. So similar to a barrel, we are going to make the flames, okay? So class flame, and then pygame.sprite.sprite. It's going to look initially a good bit like the barrel because it's going to have update and it's going to have draw and it's going to have init, and we're going to check if it can climb up ladders. So everything we learned about barrel, there's going to be a lot of overlap between the flame, but it's still unique enough that I don't really want to copy. I'd rather talk about everything we need to put in here. So do the def __ init and then self, comma, and we're going to pass in X pause and Y pause when we create them. And other than that, they'll become free roaming agents after that. Still call the pygame.sprite.sprite.init function. Sprite.init function. There we go. And you don't have to pass anything into that except self. And now let's define some stuff. So self.image, here we'll go ahead and grab the fireball image that we are about to load in, not trigger, just fireball image. We are going to load that in just a second. Self.rect, we are going to set it equal to self.image.getRect. Get I don't know why I think that's funny. Okay, self.rect.center is going to be equal to, just like before, the X pause and Y pause that we pass in, and then self.position. So they'll still be animated, and so we'll keep track of that with self.pause, and we'll set equal to 1 initially. Self.count is going to be equal to 0, so hopefully you're still seeing the familiarities. Self.xCount. So something about these fireballs is we want them to kind of bounce back and forth in a seemingly random pattern, but we want them to overall move towards advancing up the screen. So xCount, we're going to set that equal to 0, but we're going to use that variable to help us track overall this like perceived randomness with still an overall direction. All right, so self.xCount equals 0. Self.xChange, they're still going to have this kind of like movement in the x direction, and so we'll hard code them in at 2 for now. Self.xmax is a variable we will use to limit how many times you can bounce in one direction or another. I'm throwing a lot of variables out here, but they're all going to have a purpose, and you're going to see them all in use. As always, if you have questions about any of this, let me know in the comments below. Self.yChange is going to be keeping track of their Y speed. And then we need to keep track of what row they're on, sort of like the barrels. But we're going to store that in an internal variable because we're going to use that to calculate those X maxes I alluded to before. And then we're going to need to check if we're climbing a ladder. And we are going to want to check whether or not we ought to climb the ladder over and over again. So we'll keep track of if we're actively climbing a ladder, as well as if we need to check if it's time to climb a ladder. Okay, so before we go any further, because I have a red squiggly underline, let's load in the fireball image. Let's come up to the rest of our images. We'll copy the line from Peach 2. We will call this one fireball, assets, images. I don't think I nested this in another folder. No, I just called it fireball. Peach, so fireball. And then actually, I have fireball and fireball 2. So let's load them both in. I don't remember using Fireball 2, but it's in my notes. So let's do it because I'd rather have it and not need it. So we have Fireball and Fireball 2, and they are section width 1.5, section height 2 for their dimensions. So let's make this 2 a 1.5, and let's make this 3 a 2. And now we have 2 images for fireballs. Very cool. And so that is the init for our defining the flame. And I propose to you guys that we are also going to have update and check climb for the fireball. So define update, and let's just say pass for now, and define check climb, and let's say pass. Check climb is going to be very similar to there we go. Check climb is going to be very similar to check fall for the barrels, and then update is going to be very similar to update. And I think, I'm not exactly sure why I didn't put draw in as well. Yes, I am, because we are just going to use PyGame's built-in groups for draw. There we go. This is a very big project, you guys, and I, trying to teach it as we go and try and keep it all straight in my head. So forgive me if there are ever lapses in mental acuity. All right, flames is also equal to pygame.sprite.group, and now let's take a look at what we want for it in the main game loop, because we have to figure out when is it time to create a new fireball. All right. And so for that, it's actually going to be when that fireball trigger variable, right? If you remember, inside of the barrels, we check if they collide in update. We check if they collide and we return fireball trigger when they collide with the barrel. Okay. So what we want to do in our main game loop is check if the fireball trigger is true. And so if it is, let's come down here underneath, and let's say if fireball trigger, if fireball trigger equals true, then, well, actually, we don't need if fireball trigger equals true because it's a Python Boolean, and we can just say we have this new flame, which is going to be equal to the class flame at position 5 times section width, there we go, comma, window height, and then -4 times section height. And that is just a good position to kind of have it pop out of the top right of the flames.add flame. Is a good spot to have it pop out of the top of the oil drum, basically, is what we were saying here. And then we're going to add that specific flame to our flames group. And then we're going to immediately set fireball trigger back equal to false. And so this is kind of a cool way of just only creating one fireball when we spawn it in. And so now let's go up to fireball trigger and let's go with true, so that this way when we boot up the game we get one fireball. And it's not going to look great, just letting you know. Tuple object is not callable. That's interesting. That's not actually what I expected to go wrong, but I did know it wasn't going to work because we are not doing anything useful with these guys just yet. So self.rect center x pause y pause. I don't actually think that's a problem. I think the problem is we haven't created update and draw just yet. Section width and then section height should be fine. says we're passing in a tuple, which should feel concerning because we're not passing in a tuple. We're passing in 2 individual arguments. Tell you what, let's make the updating, and let's make the climbing and the drawing, and then we will worry about that error message because there's a lot that needs to go into these fireball triggers, okay? So we want to do sort of like for barrel in barrels, we want to do for flame in flames, and we want to check if each individual flame is able to climb, so flame.check climb, and then we also want to basically update their position. So again, we're going to do that in update. And we also want to check for their collision, and we want to check if the player has collided with them. And so for all of those things, we're going to put that in flame.update. But what's cool, and I mentioned this and I almost did it for barrel, is you can do flames.draw like this and put it on the screen. And then flames.update like this, and it is going to draw the image of every flame, and it is going to update the overall screen just by doing it like this for the entire group, okay? So I did flame.check climb because it is something that we had to define. Draw and update come with sprite groups. So let's go ahead and build out those functions, and then we'll figure out why it's throwing me an error, even though all I'm doing is passing in an X position and a Y position. Okay, let's start building these functions out for flame. So some of the update is going to look very familiar because like with a barrel, if it wasn't touching the ground, we wanted to touch it to the ground. And update for the flame is going to look pretty similar. Basically, if self dot Y change, so Y change, because again, we want to maximize how fast these things can fall. We want it to be more of like a casual bounce. But so if it's less than 3, meaning we're not falling at a speed greater than 3, and the flame is not actively climbing a ladder, so not self dot climbing, right? Well, that means that we can go ahead and speed up the speed at which it approaches the ground. So essentially, we're saying that we want flame.y change plus equals, and I'm going to use 0.25 because I want it to be a gentle float, right? Like it's a flame, so it's not going to fall in a very heavy manner. So I think that'll look kind of cool. And then for I in range length of platforms, okay, just like before, we're going to check and see if we're touching a platform. And if self.rect.collide rect with platforms at I, then we want to say that flame.climbing is equal to false. So if we were just climbing up a ladder, once we get to the next platform because we were climbing, we want to set that back equal to false. And then we want flame.y change equal to, and this -4 is a preference for me, but I've found that every time it touches the bottom, if I immediately bounce it up at a speed of -4, it gets this really cool kind of fun bouncing effect. And so I think that is pretty cool. And now we need to remember to come back and basically say if flame collides with player's hitbox, trigger like a reset of the game. And we need to also do this to barrels. I just want to remind myself, once we put the player in there, this for I in range length of plats, this basically update inside of every flame is going to be a good spot to check if we need to reset the game once the player collides with them. Okay, but so that's kind of it for colliding with the rectangles and changing in the Y direction. Why don't we take a look at how to update the flames in the X direction? And it's a little bit tricky the way I want to do it, but I think it's actually kind of smart overall. And if you disagree with me, I'm sure you'll leave a nasty comment, so it's totally fine. Okay, if self.count is less than 15, then I'm going to add 1 to self.count plus equals 1. Otherwise, else, I'm going to say self.count is equal to 0. And what I'm going to do is, instead of how with some of the other ones we've been using like a cycle of position, like either 0 or 1, or we've used like 0, 1, 2, 3, I'm just going to do self.pause times equals -1. So it's going to cycle between -1, 1, -1, 1. And I'm going to use that to basically change between fireball and fireball flipped. And then I'm going to use slightly different images. I remember now why I did fireball and fireball 2. Because fireball and fireball 2 are actually the two different images. And then what I want is I want to cycle between these two. And then when they're flipped, because these eyes are sort of pointing at the right, in my opinion. And so when they're flipped, I want them pointed at the left. So that's why we have 2. All right. So let's go ahead and say that is how we will work on the animation. And let's just put a pin in that for a second. And every time we get to 15 seconds, I want to also say if self.xCount, so kind of the maximum amount of time I'm allowed to move in one direction or another. But if self.xCount is less than self.xmax, then I want to add 1 self.xCount. I want to add 1 to my x count. But now you're going to see the beauty, I hope the beauty of how I plan on programming this, because basically row 1, 3, and 5 go further right than right, GHT, than left overall, otherwise flip it. So the thing is, these flames do bounce back and forth, and they don't immediately climb a ladder when they come to them, but there's a chance that it happens. So what I'm going to say is, okay, most of the time I haven't hit my X max, so just keep bouncing. But otherwise, if I have hit my X max, I need to set self.xCount back equal to 0. And then I need to check if self.xChange, so xChange is greater than 0, which means I was moving to the right already. So now I'm flipping and I'm going to the left. And so if the row that I am currently on, self.row, is in either 1, 3, or 5. This is telling me I was just going to the right, and then I am on a row where overall I need to go to the right more often than I go to the left, because the ladders to climb up to the next level are over on the right for 1, 3, and 5, and they're over on the left for the rest of them. Okay, so this is kind of my pursuit logic for a flame. And I'm saying, okay, well, I was just going to the right, and now I'm going to bounce back to the left. So I want to set my x max, self.xmax, equal to something that is going to go a little bit to the left, but not as much as I'm going to the right. So my self.xmax, if I'm flipping and now bouncing back to the left, is just going to be between 3 and 6. So 3 and 6 cycles, basically between 3/4 of a second and a second and a half. But what I'm going to do is I'm going to take that whole thing and I'm going to copy it. And instead of this, I'm just going to say else, because if I don't need to go to the right, I must need to go to the left. And so now I'm saying, okay, I was just going to the right, but now I'm on a row where I need to go to the left more than to the right. And so I will say for this from 6 to 10. And you can play with these parameters if you want. They're not like hard-coded rules from the makers of Donkey Kong. But what I have found is that the flames bounce around in a seemingly random pattern, but they always overall head closer to the ladders. And so I will say otherwise now, I was just going left. I'm about to flip directions. And so now I'll say if my row is still in that 1, 3, 5, then what I want to do now is I want to go 6 to 10 more to the right, which is what I'm doing here. And then if I have to go back to the left, but I'm on a row where that's a good thing, 3 to 6 is the goal. So let me recap this, because I thought it was brilliant when I came up with it, and I don't think I just explained it the best way I could have. But I am checking every 1/4 of a second, and I am counting that as one of the maximum X count counts. And if I need to go overall farther to the right than I do to the left, because that's where the ladders for the flame to climb to get to the next platform, the whole point of the flames is they're pursuing Mario. So if I am was just going right, if I'm actively going right, I need to set a new self x max and go back to the left. But overall, I want to pursue stuff to the right. So this 3 to 6 versus 6 to 10 just means there will be some randomness in the flames movement. And strictly speaking, if you just kept getting 6s back and forth, it wouldn't move anywhere. But RNG is kind of a game of averages. And so we're saying overall it's going to move to the right, move to the left. And once we get the logic in here for climbing ladders, that's going to mean that the flames have a chance of climbing the ladders because of this code. All right, so let's go ahead and say at the end of all of this, kind of the piece that's been missing, we are then going to flip x change times minus -1. All right, so after doing all these checks every time, we are then going to change the x direction once x count is met. All right, so hope I didn't lose anybody there. Yes, that was a good bit of code. Alrighty, so now outside of this if-else statement, let's go ahead and check if self.position is equal to 1. And if it is, then we say if self.x change, and now we're handling the animation, okay? So if x change is 0, then we are going to the right. And self.image is equal to PyGame. Actually, self.image is just equal to fireball. But in our else statement, that means that we're going to the right. So self.image is equal to pygame.transform.flip our fireball image, but we are flipping it in the x direction and not in the y direction, just like that. And so this whole thing, this if position is 1, we can sort of recreate with an else, because we don't need to do if position equals 0 unless you want to do more than just the 2 images. And now we'll do else and fireball 2 and flip fireball 2. And so hopefully this gives us a bouncing little fireball on the screen. And let's go ahead and say outside of this if else now, we want to self.rect.move, and this one is straight from the rectangle function as well, move IP self.xChange, comma self.yChange. All right. And so this is moving the actual rectangle we use for collision detection and things like that. And then let's say if self.rect.top is greater than screen height. So this is, we will just, on the off chance it jumps off the edge, because we didn't tell it, it couldn't theoretically get unlucky and random and just jump off the edge of the screen. It could. So we'll say or self.rect.top is less than 0. So somehow it made it all the way to the Peach platforms and climbed up those ladders, but you managed to dodge it. Well, in either of those cases, it's gone off screen. So we just want it to essentially remove itself from the group using the self.kill function. So a lot going on in the update function, but now if you ever have problems with how your fire sprites are moving, you know right where to go, and it doesn't muddy up your overall while loop, which gets muddied enough just by the number of things we have to call in there that are part of the main game loop. So keeping it in the update function is really useful. Now, they are always going to just spawn and bounce off the right if we don't tell them how to check for climbing. And it will look a little bit like the falling for the barrels, okay? So we'll do the variable for already collided, and you just can think of climbing as falling in reverse, right? That was pretty cool of me to put it that way. That was pretty smart, Pete. But basically, we want to lock out the x change direction and just move you up or down a platform. So what we'll say is for ladder in ladders, for lad in lads, if self.rect.collideRect with lad and not climbing already, so not self.climbing, and not self.check if you've already hit a ladder, we will set self.check ladder equal to true and already collided equal to true. And then this is gonna seem kind of weird, and honestly I'm gonna ask some viewers for help here, but my code seems to be checking it several times a second. So I found like 0 to 120 actually a good amount of odds and set self.climbing equals to true. and self.y change equal to -4. So it'll start climbing up the ladder. I don't know why I have to use such high numbers. I wanted to use like there's a 1 in 5 chance every time you hit a ladder, climb that ladder. And I thought that my already collided logic would do that, but for some reason it's checking like multiple times per second. And so I found 120 is actually about the likelihood I had to use. I have not been able to spot what I would need to do differently so that every flame colliding would only need to check once. I thought that is what I was doing. So that is why I have 0 to 120 equals 120. It should work just fine. Every flame spends about a second in front of the ladder. So basically you're saying every 2 seconds you've spent in collision with the ladder, you should eventually climb due to that. But I would like it to just be the flame hits a ladder, checks once, and until all of the ladders are not colliding with it, it won't climb again. Haven't figured that one out. But yeah, if someone in the crowd knows how to fix that, just let me know. It's not really a fix, it's just an optimization. But if not already collided, self.checklad is equal to false. And so that's how we clear it out if you're not hitting a ladder the whole time. And then I actually just used this because update was getting a little bit jumbledy. But if self.rect.bottom is less than row 6y, I want to use this simple check climb function as a good spot to also check what row I'm in, and making like a check row function to just put this like very simple stuff in felt like an unnecessary step. So I'm going to say, even though it's not really anything to do with checking climbing, I'm going to put in this like if, else, if stuff to check what row I am in. So 6, 5, 4, 3, and I think I'm going to need a couple more. But so if it's less than row 6y, then that means it's higher on the screen than row 6. If it is less than row 5y, it is higher than row 5. Row 4y, and I'm doing these L-ifs because that way we can work our way down to figure out specifically what row it is on. Okay, and so then I think we just need an else self dot row equals 1. And again, I know this doesn't really have anything to do with check climb. We actually use it in the update function to move, but it's just a much easier way to put it where it's easier to read. Okay. So let's see. I think right now the way I have it, I am spawning in a flame right when I boot it up. So let's see how it moves. Oh, we messed something else up. Tuple object is not callable. Yeah, okay. Well, I think this is the issue from before that I said we would worry about later, and now it is later. So let's worry about it. Okay, to be honest, I think the issue I'm having is I just set self.rect.center. And I just stuffed those in there. You can't set things that way. You have to do it this way. You don't need those parentheses, but you should put them around here because you are setting the center of your rectangle equal to x pause, y pause. Now let's test it. All right, we get this cute, I think it's awesome, this little flame overall bouncing to the right. I guess a big test is going to be if it successfully bounces all the way over to that ladder. And that'll give us a little bit of a chance here to observe just our overall gameplay moving. I mean, Donkey Kong animating and the barrels rolling, I think looks really cool. Let's see, he's bouncing in front of the ladder, bouncing in front of the ladder. Come on, climb it. Okay, well, the movement looked pretty good. It's on level 1, and I'm going to not worry about why it didn't climb for now because honestly, it's random, so maybe it didn't get to that point. Maybe we need to fix that later, but I think the time has finally come. We're like 3 hours into this tutorial. We're 440 lines of code. By the way, the total build is about 720, so if you're keeping track of about how far through this thing we are, it's about 440 out of 220, but a lot of the remaining functionality is going to be with relation to the player. And so I actually think the time has come to integrate the player a little bit into this game. We haven't done hammers yet. We haven't done scoring yet, but the player is so important now. Mario is pretty much he needs to interact with this world that we've built. So let's go ahead and make a new player class and set this just initially player equal to and 250 and window height minus 130. For my build, lets me drop the player right into where Mario should start in the game. And so underneath barrels and flames, let's set up the player. And we need to essentially do a lot of building out the player class. This isn't just going to be a generic sprite. There's going to be a lot of custom stuff we have to build for the player. So let's go ahead and take a look at the player class before we worry too much about how to interact with the player in our main game loop. So let's come up above barrel and flame, and let's set up a new class that we will call player, okay? And this, just bear with me, the player alone, the player class, is like 100 lines of code. And we're going to do most of it right now so that then we can show how to interact with the rest of the world. So let's make the player a PyGame.Sprite. And you'll notice the biggest difference is we didn't set the player up as a group because he is unique, but he's still going to get the sprite class like the barrel and the flame. So we're going to define initial self and then X pause and then Y pause. And then we are going to call the PyGame.Sprite and then dot underscore underscore init underscore underscore. We're going to call that function pass in self, and this is going to give us access to all the sprite tools. Now the player's going to have a lot of familiar stuff. So self.yChange, which we will initially set equal to 0. Self.xSpeed, which is something we can change if we want to make it progressively easier or harder or make the player faster or slower. But I will set xSpeed equal to 0. And then self.xChange equal to 0. And then self.landed, I will initially say false and assume that the player is in air when he spawns in, and use our collision detection with platforms to actually tell us once the player has landed. I will use self.pause, initially set up to 0 to check how often we should change the animation for the player. Self.direction equal to 1, so we can track whether we're going left or right. Self.count equal to 0, which again we will use for animating the player. Self.climbing, which we will use to check if the player is on a ladder actively going up and down, and we'll set that equal to false. Self.image, when we first load this in, I want Mario to be standing, okay? So there's standing, running, jumping, standing with a hammer, jumping with a hammer, climbing. There's a lot of images that we need to load in, and we're going to do that once we finish this init function. But for now, let's say self.image is equal to standing, okay? Self.hammer, to keep track of whether or not we're actively holding one of the hammers, will be equal to false. You don't start with a hammer. Self.maxHammer. I actually didn't look this up, but this is a variable we're going to use for how long we want the player to have a hammer once he grabs one. And I'm going to say 450 ticks, which is like 13 seconds, 12 and a half seconds. You can change that. If you know what the actual value is, feel free to put that in there. And then the length we've been holding the hammer. So how long we should have left in this hammer session. And we will decrement this, so we will subtract time from this when we pick up a hammer once we get to that point. But for now, self.hammer length, we'll set it initially equal to the maximum hammer time. And then self.hammer position, so we are going to separately track the animation of our character when he has a hammer than when he is just standing. And so we'll make that its own thing. Excuse me. And now let's go ahead and do the more traditional stuff. So self.rect is going to be self.image.get the rectangle for the player, and then parentheses there. And then the self.hitbox. So this is going to be a slightly different thing than the image when we're holding the hammer, because the image has the hammer in it, but the hammer has a different hitbox than the player. So initially, we're going to set self.hitbox equal to self.rect, but then when we get into the update and draw and calculate hitbox functions, we're actually going to take a look at how to calculate it based on the status of our player. And then self.hammerbox is going to be the hitbox of the hammer. And initially, we'll set it equal to self.rect because we'll be building functions that will update this in a more intelligent way, but we have to initialize them here. So self.rect.center, and this time I'm going to correctly use the equals sign and equals xpos, ypos when we first create the player. And then we need to keep track of his feet as well for collision with the platform. So we want when you're climbing, it doesn't think, oh, my head is colliding with the platform. Now I'm on the platform. We only want it to do that if the bottom of the player is colliding with the platform. So that'll be pygame.rect.rect. And then it'll be self.rect.left for the x coordinate and self.rect.bottom minus, we'll do 20. For the player. So self.rect.bottom minus 20. And then for width, we will use self.rect.width. And then we will make that 20 tall. Okay, so this is the bottom 20 pixels of the player's feet. And again, I like to do hand wavy, let you know what's coming, but not yet tell you about it stuff. So we will make update and we'll just do pass. And then we will do define draw and self. And then we will just put in here pass. And then we are going to go ahead and do one more, calculate hitbox for the player. So this is going to be something really useful when we have the hammer and we need to actually calculate what part of the player colliding with a flame or a barrel or a ladder or a bridge is important. So before we fill in these, which are all going to be super important, let's go load in a ton of images because a lot of the images remaining are all related to Mario. All right. So they're all inside the Mario folder, which is nice, and you can take a look through them. We have standing, and they look terrible blown up, but they look pretty good down at the size of our game that we'll be playing them with, okay? So we have standing, running, jumping, hammer standing, hammer overhead, hammer jumping, climbing 1, and climbing 2. And this is what we're going to use to animate everything. So let's go ahead and just start loading these in. Standing is going to be equal to, and I'm going to copy one of these transform.scales. And then once we do standing, we're going to reuse the standing logic for most of the other ones. So let's go ahead and do standing. And the Mario images are almost all, except for the hammer, almost all 2 by 2.5. So 2 times section width and then 2.5 times section height worked out really well. And let's go ahead and do standing and jumping and running. Those will be the first 3 we do. So standing, jumping, running, and then standing, jumping, running. There we go. So we have standing, jumping, running. Let's go ahead and do the 2 climbing. So climbing 1. And this I called climbing 1. Nice, very consistent. Good, Pete. Good work. And now let's go ahead and do, I'm going a little crazy. We're at like 3 hours. If you guys are still watching, thank you so much. This is a really hard project to build, but I know a ton of the people on this channel have found me from big PyGame and Python projects. And so I love doing this kind of stuff, but it definitely takes a lot out of you. So thank you guys so much for bearing with me. And let me know in the comments, as always, what game we should do next. I am down for punishment. I am okay with doing this really rough stuff because I know you guys enjoy watching it. All right, so we did climbing 1, climbing 2. Let's go ahead and get hammer stand. Oh, I spelled climbing wrong, and that would have come back to haunt me. I just put a B in there, just a B. That's not good. All right, there we go. And then hammer standing. So he's standing there with the hammer held out in front of him. And this one is hammer underscore stand. And now with the hammers, we're into needing to do something a little bit different. The scaling when he's holding the hammer out in front of him is 2.5 by 2.5. And that is the scaling for hammer standing and hammer jumping. Hammer jump. And that is going to be hammer underscore jump. There we go. And then hammer overhead is the last one. And this has some unique scaling because there's no other image in the game where Mario is quite this tall. So it's 3.5 for hammer overhead. And I think I did call the image hammer overhead. Okay, so I actually believe with Sprite Sheets, which is a PyGame functionality, there might have been a simpler way of doing this. And if there was, forgive me. If you know about it, let me know about it in the comments below. But these 8 images are going to be everything we need to animate the player, which is something we will use inside of the draw function. So let's come down to the player and let's actually do update first. So let's go ahead and say, if not self.landed, meaning we are not on a platform, and not self.climbing, then we want self.yChange plus equals 0.25, okay? And then we want to preemptively self.rect.move_IP self.exchange times self.x speed. Okay, so most of the time we combine speed and exchange together, but for the player, we are going to use exchange as a directional control using like arrow keys. So left will be exchange -1, right will be exchange +1, and then we will use x speed so that we can change the player's speed if we want to. But then self.yChange, no need for that. The only real y change the player has control over is climbing or jumping, and those are kind of fixed. So now we will redefine self.bottom every scan, and we will use the self.bottom definition from up here. But we need it in update as well as initialize if we want it to consistently be updating as the player moves around. Okay? So what we want to do is if self.exchange is not equal to 0, which means I'm not standing still, or, and here's the other piece, we are climbing, so self.climbing and self.yChange is not equal to 0. Because when we are doing anything other than climbing, we want to animate Mario if he's moving to the left and to the right. But when he's climbing, we want to animate Mario if he's moving up and down. But so what we'll do is I'm going to use a really tight range for the animation, because if you've seen classic Donkey Kong, Mario is moving constantly. So if self.count is less than 3, just 3 scans, which is going to happen 20 times a second, self.count +1 plus equals 1. But then we will do else self.count is equal to 0. Okay, so every basically 15 times a second, we're going to animate Mario if you're moving to the left and to the right. And what we'll say is if self.pause is equal to 0, then we will do self.pause plus equal 1. And then we will say else, that means it's 1 basically. We'll set self.pause back to 0. So I know I've used times -1 for stuff where there's only 2 images to iterate through, and I've used checking equals and changing it. But honestly, I sort of do whatever comes to me first and then explain it. And so if you guys, the programmers, want to do it a different way, like please do. Okay? And then we will say else. So this means that X is not moving, or I'm climbing and I'm not moving in the Y direction. I'm going to hold the player in at position 0. So this will automatically snap Mario back to standing still or in the default climbing position if we're not moving. That way we don't get this goofy looking like you're stuck in the running position but you're not moving Mario. That would look silly. Okay? And now we'll say if self.hammer, so I'm actively holding the hammer in this scenario. Self.hammer position is going to be equal to, and self.hammer length, so this is how long I've been holding the hammer for, divided by, floor divided by 30, and then modulo 2. So I know this is going to sound a little bit goofy, but this 30 here is how you can control how frequently Mario switches between hammer overhead and hammer in front of him. I'm doing it every half second. It could still work at every 15 if you wanted. And the way that we do switching between two is because hammer length divided by this value will give us either an odd or an even number, basically. So if it's 300, it'll go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then by checking the modulo 2, that's always going to be either 0 or 1. So this is kind of a funky formula to check based on whatever value we put here and then iterate between the two positions he has when he's holding a hammer. All right. And then we're going to subtract 1 from hammer length. So we're basically counting down the amount of time we have the hammer. And then what we do is we say if we've gotten to self.hammer length equal to 0, that means that we've used up our hammer time. So self.hammer time equals false. And then self.hammer length is going to go back to self.max hammer. Okay, so we want to reset the time when we're done with the hammer. And so this is kind of all we need to do to check like the default updating stuff. But there's not a lot of handling of X position and Y position in here. And part of that is because we are going to put in this event handling, which is where we put the quit. We're going to put a lot of player controls in here too. But one more thing I do want to do is calculate whether or not we're landed. And so to do that, let's actually come above the if not self.landed and do if, and this is going to get a little bit crazy, okay? But let's do if not, what do I want to do here? To check if the player is landed, we want to do that in here. We want to do checking for the player colliding with all of the platforms. So let's go ahead and say for I think we've done this for all of the sprites. For I in range length plats, let's go ahead and say if player, and again, just the bottom. So player.bottom.collide rect, and it's not bottom meaning derriere, it's bottom meaning feet, you weirdos. Okay, if it collides with rectangle plats at I, then we want to set player landed equal to true, and then we want to say if not player self.climbing, not player, self.climbing, and self.landed, and this shouldn't be player.bottom, that's silly. Let's say self.bottom because we are in the player class. We'll set self.landed equal to true. And then also, if not self.climbing, then we want to set player rect.center y. So we want to just move them to the top of the platform to make sure you don't get a weird thing. Like if you jump from level to level, we don't want you weirdly like stuck a few pixels below the platform. So we will say the center y should go to plats I dot top and then minus player dot rect dot height divided by 2. So remember we're doing center y, so not player rect, self rect. I am struggling mightily here. Self.rect.center y, self.rect.height divided by 2. And then honestly, just throw a +1 pixel on here because otherwise the player's constantly going to be falling 1 pixel, scooting him up 1 pixel, falling 1 pixel. So just scoot it down 1 pixel and that is perfect. And then that should be all we need to do to handle the player colliding with the platform. So I think what we want to do now is, should we do drawing or should we do player controls? Okay, well, I'm not getting a lot of feedback from you guys because this is not live. So let's go ahead and dive into the draw function and then we'll calculate the hitbox and then I'm thinking we'll handle player controls. I know there's a lot going on here. I appreciate you guys sticking with me and we are going to get through all of it if I'm just not sure what order yet. But okay, if not self.hammer for this whole section, then we want to say if we're not climbing, so if not self.climbing and we're landed, okay, so self.landed. Now we need to check if self.pause equals 0, then we want self.image to be equal to standing. Otherwise, self.image can be equal to running, okay? So that means we are not climbing and we are landed. But now, if not self.landed, that means we are in the air and we are not climbing. So those are the two scenarios where we might not be landed, if we are either climbing or we are jumping. So if we're not climbing, not self dot climbing, and we are not landed, then we must be in the air. That means self.image equals jumping. And we're not going to animate you while you're jumping. When you're jumping, you're going to be this like Mario in the air position. That's just like by default how we're going to leave it. Okay, so self.image equals jumping. And then we will go and say, okay, next if self.climbing, then we want to check if self.pause equal to 0, then self.image is going to be equal to climbing 1. So remember, this is just a 2-position climbing animation. So self.pause equals 0, climbing 1. Otherwise, self.image equals climbing 2. Okay? And so that is it for the self.climbing animation, but all of this was underneath the banner of what to do if we do not have the hammer. Now, if we do have the hammer, so if it is self.hammer, if self.hammer position is equal to 0, then self.image is equal to hammer jump. Yeah, self.image is equal to hammer jump. And then we will say else self.image equals hammer overhead. Else self.image equals hammer overhead. I have an extra colon in here. Let's get rid of that. Scroll down a little bit. It says I have an error in here. No, it doesn't. It cleared. We're clear, everybody. And now let's go ahead and say if, oh, okay, I know what. I used hammer jump instead of hammer stand because hammer jump and hammer overhead are really similar. And I honestly don't think we need hammer stand at any point. I think we can just use hammer jump for stand and jumping. And so I think the way I set this up is the whole time you have the hammer, no matter what, we're just going to cycle between overhead and smashing. I actually don't know for certain if that is how it works, but I think the gameplay I watched, it was just always oscillating between overhead and smashing. All right, so equals hammer overhead. Now we need another important check, which is if self.direction is equal to -1. So that means that we are going left. All these images are oriented facing right. We're going to do self.image equals PyGame.transform.flip. There we go. Self.image. So the already defined self.image, we're going to flip it in the X direction, not in the Y direction. And then let's go ahead and say else. So just to be crystal clear about this, self.image equals self.image. I don't know why I put that else in here, but I have a note that says must include. That might be a lie, but I'm not going to question past self now. All right, then we will internally call the self.calc hitbox function just because we don't have to call player.calc hitbox every single loop because we're going to be calling draw self every single loop, and I know we want to calculate the hitbox, so we may as well put that inside the draw function. Now what I'm going to do is say if self.hammer position is equal to 1 and self.hammer, so we actually have the hammer, then we are going to screen.blit self.image in position. Oop, that's an and for everybody. Self.image. And so the coordinates for where to blit the image, this is saying I'm facing right and I have the hammer and I'm in the position where the hammer is getting slammed down or overhead, excuse me. Self.rect.left, comma, self.rect.top minus section height. So remember, the hammer overhead is actually one section height taller than all the other images. And unfortunately, well, it's not really unfortunate, it just is what it is. But the way PyGame draws images is based on the top left coordinate. So in the sole case that we actively have the hammer and the hammer is overhead, we need to draw the image one level higher. But other than that, we can always just screen.blit the image onto the screen without this minus section.height. So at the top left, all right, just like that. And I think I have unnecessary parentheses again. Screen.blit, self.image. Oh, yeah. So I can actually, instead of using self.left and self.top, I can just do top left, which is a tuple of those coordinates. Okay? So that should be it for draw. And we are getting really close to being done with the player kind of class logic, and then we can just integrate it into our main game loop, which is really cool. But let's dive into the calc hitbox function. We are getting so close, and even though I am getting tired, this is really rewarding, so let's keep going. If we do not have self.hammer, that makes the hitbox really simple. Self.hitbox is going to be equal to pygame.rect.rect. And again, I'm doing it this way because I don't want to draw it on the screen, but I do want to define a rectangle that is different than the overall image. The overall image always has a pretty good amount of like margin on the sides and the top and the bottom. And we want pretty tight collision detection here. So we're going to define our own custom hitbox. Excuse me. A little bit of hiccups going on, so much talking. Okay, but so the hitbox is going to be self.rect. A lot of it's going to be based on the rectangle of the image, but we're going to tighten it up a little bit so we're not colliding with white space. And so self.rect 0, which is our normal X start, just scooted in 15 pixels to the right. And then self.rect 1 just scooted down a little bit so we're not colliding with the like empty space above the head. And that's our X and Y start position. Now our width, self.rect 2, which is our full rectangle width, minus 30. So you get that 15 margin on both sides. And then self.rect 3 minus 10. So you have a little bit of margin above your feet and below your head on the hitbox. And that is all we have to do if we don't have a hammer. It's pretty simple. The problem is that if we do have a hammer, then we have to calculate the hitbox of the hammer and the player independently. So let's go ahead and say elif. So now elif meaning else. We do have a hammer, but then we also need to check the position of the hammer. So if hammer pause is equal to 0, and this is actually further dependent on the direction of the player. So if you're facing to the right, then it's going to be different. So let's go ahead and say pass for a second. Oop, Control Z. Pass for a second so that I can show otherwise. So this else is saying I'm in hammer position 0, which means it's horizontal. Mario is holding it out in front of him. And then this is facing right. And then this is facing left. But then we need one more else, which means I do have the hammer and it's over my head. Okay, so that is what all these different zones are. Let's start building out each individual hitbox for it. So we're going to have both a self.hitbox and a self.hammer box in all of these. So self.hitbox. And we're going to change the player's hitbox a little bit here. We're actually going to start all the way on the left edge of this one because it's a little bit wider and the player is all the way in the back. So we're going to start at the left edge for this one. We're still going to go down 5 pixels off the top, and we're still going to make it the same width, this self.rect 2 minus 30 and self.rect 3 minus 10. So the player hitbox doesn't change a ton other than it scoots now to the left edge of the image. But then pygame.rect.rect for the hammer hitbox is going to be self.hitbox. So we're going to reference some of the work we just did. It's going to be the left edge of the hitbox minus self.hitbox 2. So it's going to be the left edge of the hitbox, but then even further back by the width of the hitbox. And actually, I'm sorry, it's going to be plus the width plus the width of the hitbox. So it's the same left edge, but then it starts at the right edge of the player. Okay? And then what we want to do is we want to say comma self dot, and then the Y starting position can be exactly the same. Self dot rect 1 plus 5. because we're basically now saying there's this invisible rectangle to the right of the actual player's image, which is a hammer. And if the hammer hits a barrel, it's going to protect the player and destroy the hammer. And so then in terms of width, it's just going to be a little bit less wide than the actual player itself. So self.rect2 minus 15. And then in terms of height, self.rect3 minus 10. We're going to keep it the same, self.rect3 minus 10. We're going to keep it the same height as the full-blown one. Okay, so that is if we are facing to the right. Let's copy these down and amend them for if we are facing to the left. And basically, it's the same shape rectangle for the player, but it's got to scoot about 40 to the right. If you don't trust my numbers or you're building a slightly different version of it, feel free to play around with the hitbox or even draw them on the screen so that you can see them as you build them. We are 3.5 hours into this, so I'm not going to do that, but you absolutely could to see where I'm getting these values from. But basically now instead of saying left edge plus the width of the player's hitbox, we are going to say left edge minus the width of the player's hitbox for the X starting position. And then I think everything else can get left as is. In an interesting bit of inconsistency, for one of my hitboxes, I used the same width as self.hitbox2, like this. So that was the hitbox's width. And then for the other one, I had self.rect2 minus 15, which is interesting. But I guess what I will do is make them both self.hitbox2. And hopefully that works out just fine. Okay, now the last thing we have to do is we have to define a player hitbox and a hammer box if the hammer is overhead. Unfortunately, this is symmetrical, so we don't need one for if we're facing left and facing right. It's going to be the same boxes. So let's go ahead and make this back to 15. It's going to look a lot more like the player hitbox for when we were doing the regular player, but now we need this self.rect3 minus 10 for the height and self.rect1 plus 5. The overall hitbox for the player does not really need to change a whole lot when it's overhead. The biggest thing that changes is the hitbox now is a big rectangle over the player's head. So I still kind of like the idea for the X hitbox of keeping the hammer box start on the same X position as the player's hitbox. But now here, we're going to take self.hitbox1, which is wherever the player's hitbox starts, and we'll say minus section height. So we have one section height square above the player's head when the hammer is overhead. That is going to be what we use for how tall it should be. And then we'll make it as wide as the player hitbox, and we will make it one section height. So this gives us a hammer hitbox directly above the player's head of one section height that kind of protects you from barrels overhead when you're holding it overhead. It's pretty similar to how Mario uses it, I think. Okay, so that was a ton in the player class, but if we did it right, we are not going to need to come back up here unless we're doing some troubleshooting, which we probably will be. But let's go ahead and look at the biggest thing we haven't really touched on yet, which is player controls, okay? Okay, so right before we dive into player controls, before I forget, let's just throw player.update and player.draw right here as well, because those are things that we need to have. And then what's kind of neat is I'm going to reset the player.landed out here and set it equal to false. So this way, every loop, it's going to assume it's in the air and have to essentially prove to itself that it's not. This would still be valid if you wanted to, and actually maybe I will move it into the player.update function. So let's do that, actually. I don't know why I thought it'd be cool to put it down there. Let's go ahead and say self.landed equals false and just start every loop assuming that we're in the air. And that way we have to essentially prove that we're not. Otherwise, we have to treat it as if we are. Okay, so just a few things before we dive into the controls, and now let's dive into the controls. I'm sure we have missed some other stuff in the past, and we will have to correct as we start troubleshooting when we play. But let's add a few new categories here, okay? So let's add if event.type is equal to PyGame.keyDown, and then let's just put pass in here for now, and add an if event.type is equal to PyGame.keyUp. Okay, so let's go ahead and put these two categories in, and basically the keys we're going to use are left and right for left and right movement, space for jumping, up and down for climbing up and down ladders, and basically that is all the player controls we need. It sounds simple, but we have to figure out how to appropriately have it interact with the player. So let's just take a look at right first. Okay, so if event.key is equal to pygame.k_right, and there's just one other thing I want to put here, and not player.climbing. So basically, there's this really easy event handling in PyGame, this for event in PyGame. This is where I want to put all the event handling, but we need to determine what to tell the player to do based on a lot of player input. So if we're not climbing, then at any other time, we're able to change in the right direction. We're able to go player.xChange equals 1, right? So that's what we decided the right would be. And then player.dir, which is direction, is equal to 1, okay? And so we can copy this whole thing, which is kind of cool. And we can change this right to a left. And we can say, now I want the xChange to be equal to -1 and the direction to be -1. And now it's not really useful per se, but I'm going to copy it again and do k space this time. And we need, instead of not player climbing, we actually need it to be player.landed. Okay, so we need to know that the player is on the ground, otherwise we can't jump. But if we hit space and the player is landed, then the first thing we're going to do is set player.landed equal to false, okay? Which is kind of an extra step because we do that every time anyways. But we're going to do player.landed equals false. And then player.yPause equals. And this is kind of a sneaky little trick here. But I have to say plats I.top -1. No, that we don't need. I think that is an error in my notes. Player.yChange equal to -6 is all we have to do. And this should give us an upwards jump of essentially 6 pixels initially. And you're immediately going to start slowing down because we built in gravity. But this yChange is what's going to get you off of the platform so that you're no longer landed. Okay? And so maybe now let's go ahead and take a look at up and down. And those really only do things if we're climbing, but they're how you enter climbing. So if event.key is equal to pygame dot and then k up, then what we want to do is say if I'm able to climb. So we're going to need a new variable to check if the player is able to climb. But if they're able to climb, we will say, okay, player dot yChange is equal to -2. So now you're climbing upwards, and player dot xChange is going to be equal to 0 because now you are not able to move in the x direction, and we will set player dot climbing equal to true. Okay, and then we will say kind of the same thing for down, but we're going to have to do a sneaky extra check. If you remember how we checked if barrels were able to fall, we need a rectangle under the player to check. So we will make that down instead of climb. But anyways, beyond that, it's sort of the same in reverse. We make the yChange equal to 2, we make the xChange 0, and we set climbing equal to true. So we have to get these climb and down variables from somewhere. Just keep that in the back of your mind until we put the rest of the player controls in, and then we will take care of kind of how to actually make them do stuff. So I'm going to copy all of those keys into key up and just get rid of space, because space is the only one where releasing it doesn't really change anything. And when you release the right key, we are going to make the X change equal to 0. And I'm not going to change the direction whatsoever. So the whole thing is when you release the left and right keys, we're going to leave you in whatever direction you were already in, but we are going to change your X change to 0 so that you're no longer moving. And now what we'll say is when you release K up, if you're climbing, then change the Y change back to 0. We don't have to do anything for the X change because we were already taking care of that. And then what we will say for releasing down, if you are climbing and you go down, then what we want to do is set player Y change equal to 0. But we need down to do one more thing. We need to check if the player is climbing, so player.climbing and player.landed, then we want to use this to unlatch the climbing condition. So basically, you're going downward, 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 and then, oh, you hit a platform, but it still says that you're climbing. We're going to unlatch the player.climbing condition here. Okay? And so we went through that kind of fast, but that is actually all of the player interaction we need to build. The only thing now is we have to get how to tell whether the player can climb and go down. We need to get that from somewhere. And so I propose that this is a pretty simple thing we can build into a function or as part of the player class. It uses all of the ladders and the player. So I think there's a few valid ways to do it, but let's go up to the oil drum coming from draw extras. And let's just say we're going to get climb and we're going to get down from a function that we'll build called check climb. And this is just going to help me keep my brain straight on where everything lives because we're at like 600 lines of code now. So let's go ahead and say check climb. And we don't have to pass anything in here, but we do have to pass climb and down back. So let's just go ahead and return two variables. You can climb and climb down is what I'll call them to keep them, I guess, straight. Maybe that's confusing naming. But all right, basically every time this is called, we will start by assuming that it's false. So we'll start by assuming that can climb equals false. Isabel is calling me. 1 second. Okay, apologies, I got a call. So if there's any blip in the recording from what I was just saying to what I'm saying now, I just had to take a phone call. But in our check climb function, we're going to go ahead and start by assuming that you are not able to climb and that you can't climb down. And we will essentially make it prove that those things are actually true. So we're going to define a rectangle in here that's fairly similar to the player's bottom, like the feet already, but this one's going to be more like that barrel or the hammer, how we actually check above the object so we know if it's colliding. And so for this rectangle, we are going to use player.rect and then their 0 argument, so it'll have the same X position, but then the player.rect position Y, which is 1, we're actually going to add 2 times section height to it. So this is going to check basically from the player's Y starting position, but 2 section heights lower. And if you remember, Mario is actually 2 section heights. So the start of the rectangle will be at Mario's feet. And then the player.rect 2 is going to be the width of this rectangle. So it'll be the same width as the player's regular rectangle. And then we'll say player.rect 3. So it'll be the full height of the player just set 2 sections lower than the regular player rectangle. So we're essentially shifting the player's rectangle down 2 section heights so we can check for collision. And then we're going to do something familiar for lad in ladders. And we're just going to say if player.rect.collideRect lad, then we can go ahead and say can underscore climb equals true. And actually, I'm going to add a if in here. So to say and can climb is false, because once we've checked that it collides with 1, we don't need to check if it collides with the rest. This is not strictly speaking necessary. Your program will still work, but you're going to save some compute time. And in a really big game, looking for those opportunities is actually pretty important. So if the player's rectangle, just to reiterate what we're doing here, collides with one of those climbable rectangles and it wasn't already saying that we're able to climb, then we set can climb equal to true. But then if under collides with the rectangle, and we collide with the ladder, then that means we can climb down. So this is actually really important, because when you are on a platform, your player rectangle is not going to collide with a ladder below you, but it is going to collide with a ladder that you can climb upwards. But while you're on the platform and there's a good ladder below that platform, your under rectangle will collide with it, but your regular player rectangle won't. So that's kind of the benefit of having the player rectangle and the under rectangle separately. All right, so let's go ahead and minimize that check climb function. We'll only come back to it if something is wrong. And I think we're at the point where we can boot this thing up and hopefully we will get our little animated Mario with player characters running around. We haven't done any losing life or anything, so it should be pretty much a sandbox we can play around in. And yeah, I move left and right and you get this classic looking Mario animation that I just think is so satisfying. You hit space and you jump. If you go up and down platforms, you can see its Y position automatically go up and down. It's not quite a strong enough jump that I can just jump from level to level, so I have to take a ladder. And let's see now. Okay, I'm trying to press the up key and the down key, and it's not letting me have the player start climbing. So looks like left and right is working great, and up and down needs a little bit of attention. So let's come back to our up and down function, which is going to use climb and down. Okay, I don't know if this is for sure what the whole issue was, but in my notes I do have here, we have to say if climb, but then we also have to check if the player is actively climbing and we get the player.landed status, then we need to set climbing back equal to false. I don't think this is what the issue we were just having was, but this is how we check when we've climbed all the way up and we get to a new platform. This is how we check that we need to stop climbing and now we're on that platform. So I don't think that was the only issue. I guess let's boot this up and see if we can climb that ladder again. And actually, I think I'm still printing in one of these. I'm still printing a few things for maybe that was the player or the barrel. It was something about, or maybe it was draw a Kong, because I was drawing a few things to troubleshoot. I'm going to get rid of this print, but I do want to add, I think now just at the bottom for some troubleshooting, I am going to print out the if I'm able to climb as well as the down status. So I'm going to print those two things in my terminal just as a little troubleshooting trick. And they're both false, which is good because I'm not colliding with any ladders. But now, okay, so they're still both false. So something in our checking is not working because we should be able to climb now. So let's go ahead and figure out what could be going wrong. Okay, so an obvious thing, but not the issue, I'm sure, is that we didn't set climb down equal to true. But since we're trying to climb up, I don't think that's the problem. I think the problem is likely the body of the ladder. I want to take a look at when we defined that because I think, so we made it a rectangle. It starts at the left edge, which is correct. And that starts at the self.ypause minus section height, which is self.ypause minus section height, which is a little bit above the ladder. And then section height, section width, ladder height times the length plus section height. I don't think this body rectangle is working. So let's try pygame.draw.rect. Put it on the screen. Let's just make it red so it pops a little bit, and let's draw this body rectangle. And so every ladder that you can climb should have a body rectangle on it. And what's kind of interesting is like this one, each of them has one, and it's at the very top, but it does not span the whole length of it. And so somehow I must have done some math wrong here. Self.length times ladder height. Oh, times section height, I bet. Times section height. Because ladder height is 0.6, but we have to multiply that by section height. Let's see that. Okay. I am almost sure that was the problem. So let's get rid of this pygame.draw.rect. We need the ladder height times length times section height. Now let's take a look if we can climb those ladders. So we take our player, we go running, jumping, and I get to this ladder. I'm on the ground. I can climb up. I can stop on the ladder, which is cool. When I get down, it looks like it does detect if you release it when you're close to the platform. And then when you go up, oh, that's interesting. It didn't stop while I was going up. Okay, so I think we need to figure out why. Oh, it counts on the player to release it during the right time. Otherwise, yeah. Otherwise, you just climb forever on an invisible ladder. Okay, so it looks pretty sweet, but we need to figure out unlatching the player climbing stuff here. So I think a natural place to kind of add in some functionality would be inside of this check climb function. Let's just add a new check, which is going to be if we're not able to climb. So if not can climb. And so we're going to stack some conditionals here. Try to bear with me. If you cannot currently climb, so that means the player is not currently connected with a rectangle, and you cannot currently climb down, so climb down, or the player, so player dot y change is less than 0, meaning that you are going upwards. And so that is going to be one condition. Or, all right, and again, I'm going to get all these down there and then explain a little bit better what we're saying here. But or the player is landed and we can climb, but the player y is going downward. So player dot y change is upward, greater than 0. No, that is downward, and not climb down. Okay, so I'm gonna put this on a second line so it's not quite such a run-on here and talk about what we're saying. But basically, if either of these things are true, we want to set player.climbing back equal to false, regardless of if we were climbing or not. Okay, so we need, what do we need here? Like a new line, I guess. There we go. Excuse me. So what we are saying is two conditions that could automatically unlatch the player climbing bit. And this should handle how we just saw the player climbed off the screen. The first is you're not currently able to climb. So the player is not combined with a ladder anymore. And so that'll mean when you're climbing upwards, as soon as the player rectangle clears it, and one of these two things is true. So either the player's y change is negative, which means we're going upwards, or you are not able to climb down, which means below you is not a valid way for you to go. So that means that you are already at the bottom of a ladder. Or we could have this. The player is currently landed, meaning in contact with the bottom platform, and you are able to climb, but you're actively trying to climb downward. So player y change is positive, and you're not able to climb down. This one line of code, although it's a little complicated, is basically how we need to check to make sure to stop the player climbing in either direction. I'm fairly confident now that when we boot this up, if I try to climb on a ladder up or down, it'll automatically stop when I get to the top. So let's check it out. Okay, that actually looks, he finishes with a little jump. And then I try to climb down, and I tried to hold down. And so that looks really good in the up and down. I think we solved that problem. So I guess the player sprite is actually looking really good. The movement is super satisfying. And so I think what we should do is probably cook up the hammers. And then I don't really want to put in like life tracking and losing lives until we've got the hammer working, the scoring working, the victory working and everything, so that I can sort of test this game just by like playing through it and not worrying if I'm actually getting hit by a barrel or not. But so overall, it looks really cool. It's already super satisfying to move around. So we're getting really, really close here, everybody. And so let's go ahead and put the hammers in. I think this is going to be a satisfying little bit of code. And I think we set up the player class in a way that's going to make this fairly easy. So one thing is there's going to be multiple hammers on every like board, and ordinarily I would say if there's going to be multiple of something and they all need to behave similarly, and interact with the player and other sprites, let's make it a list. So let's go ahead and say that hammers is going to be equal to pygame.sprite.group, okay? Just like that, just like the other two have been. And then this is probably something where the best place to initialize it would actually be here in the beginning, because the list is not going to change during the game. So like with fire sprites and barrels, they can pop up and have new ones during the game as part of the game, but the hammers are set in the beginning. So let's go ahead and make a hammers list. So we'll say hammers list is going to be equal to, and we'll do levels, active level. So this is going to look a lot like what we did for ladders and bridges. And here we'll say hammers. Now we don't have the hammers in there yet. There's just 2 for this level, but this will also make it to where if you want to build more levels, you just have to make a new dictionary key value pair with your hammers. Okay, so we'll make our hammers list, and then we'll say for ham in hammers list, let's go ahead and add hammers.add, and we will add a instance of a class hammer that we're about to make. And we're going to just unpack ham. Okay, so we're going to unpack that item just like we have with the other ones. Let's come up to our levels list, and I'm not going to expand it out here because bridges and ladders can stay collapsed. But let's go ahead and add an item for hammers. And there's only 2 in level 1, but this is a fun little thing you can play around with. If you want to add a 3rd hammer, go ahead. But so I played around for a while with position, and I just found that the 4 times the section width was a good spot for the X coordinate of the first one. And then its position, using that row 6 top variable, and then adding to it section height. So row 6 top plus section height was good for one of the hammers. And then the other one is right below it, so still 4 times section width, which again we put inside the class. And then row 4 top plus section height worked just as well for the second hammer. So just like this, we should have now our list of hammers that needs to go into our levels dictionary. And actually, shoot, there we go. The dictionary has to be at the end of this list item. So make sure you've got your open close to the dictionary. The reason I put it in a dictionary is because this would allow you to make a second level and put it here. And this would be like level 2 stuff. Okay, so if you want to design more levels, just use this same format. And then when you beat the first level, it'll automatically, you increment level by 1 to go to active level the next index, and it'll draw your board for you the way we set this up. Okay, so let's come below our player sprite class and above our barrel sprite class, and let's go ahead and say class hammer. All right, and we're just gonna make this also a pygame.sprite.sprite. And it's going to have some familiar stuff. It's going to have init and it's going to have draw, but it's going to be a lot simpler than those guys, I promise. So pygame.sprite.sprite, and we are going to still call def dunder init self x pause and y pause, and that is all we have to do because the hammer is an image and we will get the rectangle off of it. So self.image, let's pull in an image in just a second called hammer. And then let's go ahead and make the rectangle self.rect is going to equal pygame actually not pygame, self.image.getRect of our image, and then just open close parentheses. And then self.rect.top is going to be equal to the y position that we pass in, and then self.rect.left is going to be equal to xpos times section width. And then there's only one variable we really need to keep track of here, and that's going to be has it been used or not. So once it's collided with, it'll be used. We're going to make it invisible at that point, but we're still going to leave it there because when you reset a level, like you lose a life, the hammers come back. So we're going to use self.used instead of self.kill. All right, so define draw self. And this is just going to be if not self.used. So we haven't already been used. Then let's screen.blit the self.image onto the screen, and our coordinates are just self.rect0 and self.rect1. We got the coordinates of our rectangle off of the image. Now we're blitting the image using the rectangle. It's kind of cool. Okay. So if self.rect.collide rect with the player self.hitbox, right? So not the overall rectangle. That's a bit overkill. Then we'll use self.kill because it'll reinstantiate when we reset the game. But we want player.hammer to be set equal to true. And then we want player.hammer length. So just in case they catch a second hammer and the first hammer was not yet through, we're going to set player hammer length equal to max hammer. And then we're going to set self.used equal to true. Okay, so only thing we need to do to get this hammer class working is go to the images and make sure that we load in our actual hammer. So let's come under where we loaded in the fireball, because it's kind of in that class of object, kind of in those stationary things you interact with. And we will call this hammer. And now let's go ahead and do pygame.transform.scale, assets, images, and there it is, hammer PNG. And this one is not a real big image, so 2x2 kind of works for the square. So 2 times section width and 2 times section height. And then I think the only other thing we have to do is make sure that in our main game loop, we draw all of the hammers. So we'll do for ham and hammers dot draw. Let's see if we come down in the main game loop. We have the player down there, player dot draw. Let's see if I can do hammers dot draw. Will that work? Let's try. Run and, oh, screen? Let's try that. No. Okay, it is way too late in this tutorial for this to hang us up, so I'm going to do it the way I'm sure will work for ham in hammers, ham dot draw, just like that. Okay, let's try that instead. And, oh, still did something wrong. Okay, hammer has no attribute sprite. That is curious. For ham in hammers list, hammers.add, and then this is for ham in hammers, ham.draw. That's pretty straightforward. What are we doing wrong? Oh boy, I'm silly. That's what happens when you get 4 hours into a tutorial. The first thing we do when we have one of these init functions has to be call that sprite image init function. So pygame.sprite.sprite and then dot underscore underscore init underscore underscore and then self. Okay, so by doing that, I think any of what we just did would work. I mean, let's try it really quickly here. Let's just try hammers.draw and see if that's enough. Hammers.draw. Let's try booting it up now. It still didn't like it. Missing, oh, on the screen. Goodness gracious. What a day. Okay, so there we have 2 hammers. Let's see if I can go grab one. Hopefully, all that hammer logic we set up for the player will work perfectly when we grab this. All right, so I'm colliding with the hammer box, so I thought, and I thought the drawing would have removed that hammer from the game. So let's take a look, see, make sure the second one does the same thing. Yeah, and the player's hammer is not coming forward. Maybe we never, let's take a look. Let's go back into hammers.draw. Because I think what we might need to do is actually this for ham and hammers, because we overwrote the default PyGame group. So for ham in hammers list, I think ham.draw might be what we have to do, because the default for .draw for a sprite group tuple has no object draw for ham and, oh, it's because it's not in hammers list. Dang it, man, I am struggle bussing. For ham in hammers, ham.draw. Let's take a look here if we can grab those hammers, if they go away, and then if we are holding a hammer for that 450 that we set up. Bang. Okay, there we go. And now he's cycling between having the hammer and not. If we were to draw the hitboxes on here, I think we'd see that we have a different hitbox overhead when we are swinging the hammer forwards, and then it goes away after a set amount of time. So, okay, we're getting really, really close. Let's make it to where if those hammers hit a barrel, it removes the barrel. This should be pretty easy. So I personally think you could make the argument that you could interact with the player or the barrel to eliminate the barrels. But I think because we have this for barrel in barrels, barrel.draw, barrel.check fall line of code down here, we could actually put it in the main game loop, and we could just say if barrel.rect.collide rect with the player.hammer box, right? So the hitbox for the hammer, and player.hammer is active, then we will just barrel.kill, and then we will say score plus equals 500. So we haven't introduced score yet. We're going to have to now because we're removing barrels. But if the hammer of the player hits a barrel, we should remove the barrel from the sprite group, and then we should add 500 to the player's score. So let's go ahead, and we're not going to do anything with the score just yet until we get back to like drawing the score and the high score and the bonus on the screen. But let's go ahead and make the variable score, high score, and bonus right here. And bonus initially I'm going to make 6,000. We'll talk about the weird kind of bonus in Mario in a little bit. But so we have active level here, and let's just make a lives variable equal to 5. So we are going to need these once we get to drawing the rest of the things on the screen. But for now, let's just make those variables so we can test and see if we're actually hitting hammers and getting rid of them now. Okay, so let's go get a hammer, and then let's go hit a barrel. And honestly, I love moving around in this game world that we made. It's really cool. So let's see if I can do smash. Okay, and we got rid of it. I think that's awesome. And then let's see if we get this one. Yeah, so boom, boom, smash it while it's down. Maybe I can hit this one from underneath. Yes, I can, and it worked. Okay, so this is really, really satisfying. We have the player. You can still get hit while you have the hammer, but you also have the ability now to remove barrels. And we're not displaying the score anywhere, so I guess the time has probably come for us, before we handle like getting hit by a barrel or the flame sprite and losing a life and resetting, why don't we just draw the rest of the things that we've put off drawing in the draw extras. So let's go down here and let's take a look. It's just going to be a few formatted strings or F strings that we need to put on the screen in some pretty specific places. So let's go ahead and just start with the first one. So let's do screen.blit of font.render. So remember, we set up the fonts already. And this one, I think I in the game is what stands for the current score, like the individual score. So we're going to do an F string of I, and then I have the dot, like the ASCII character dot on my keypad over here, so I can copy it in. But you could use a star too if you don't know the ASCII key code for a dot. But then this is just going to be a formatted string that says the word score. And that'll be true, and we'll make that text white because it's against a black background. And then in terms of position, we will say 3 times section width, and then we will say comma 2 times section height. Okay, so it's pretty close to the top of the screen, and that is it for that one. And then again, I'm going off of this, let me close some of these. I'm going off of this classic level format where the I is over here, and then top, which I think is high score, is over here, and then this M, L, and bonus is over here. So let's go ahead and make all of these texts, okay? So that was for score. And then this formatted string will say top. So this is high score, all right, high underscore score, and then true, and then white. And this will be at 14 times section width and 2 times section height. And we will leave that in the same vertical position. And now they're going to get a little goofy, where if you need to sort of understand what I'm doing, then feel free to play around with these a little bit. But this is going to be an F string, so still formatted just because I'm trying to keep it standard, but there's no variables in this one. We're just going to make some like open and close parentheses that are going to kind of give us the spacing we need to put variables inside of them. So there's really not a super good way for me to do this other than basically make huge brackets and then do 2 rows of text inside the brackets. So I actually think it looks pretty good, and we'll go ahead and take a look at what I mean once we get this on the screen. But so you're going to have a whole bunch of spaces. This one in particular is 1, 2, just 2 spaces in between the two. And then this is 1, 2, 3, 4, 5, 6, 7, 8 if you're following along at home. And then this is 2 more. Okay, and 20 times section width and 4 times section height is where we want to put that one. And now we need to do, again, it's kind of goofy. I'm actually just going to copy these next 2 in, and then I will tell you how many spaces they work because I figured it out ahead of time. But we need the M, bonus, and L using that font too now, that smaller font that we used to draw the oil. We want it to be a formatted string and 2 spaces before the M, and then 1, 2, 3, 4 spaces, the word bonus, and then 1, 2, 3, 4, 5 spaces, the letter L, and 1 more space. At 20 times section width plus 5, so that it just moves a little further to the right. And then that same height of 4 times section height. And then for the actual F string, keeping track of our lives, our bonus, and our active level, you need a lot of spaces similarly. So you need 1, 2 spaces, and then the lives variable. And then 1, 2, 3, 4, 5, 6, 7 spaces, the bonus variable, and 1, 2, 3, 4, 5, 6, 7, 8 spaces, and then active level and 1 more space. And that's going to be at 20 times section width plus 5, but 5 times section height. Okay, that is, I know, kind of annoying and random, but I was trying to get a very specific thing going here, which you can see I put the M and the 5 inside of these big brackets, and bonus and 6,000 inside these big brackets. So I know that probably seemed kind of random, but honestly, I was trying to get it as close to the classic Donkey Kong as I could, using the like native PyGame drawing tools here. And so looking at this board, there's nothing left on the screen that we aren't doing. I would say the biggest thing that we need to add that we don't have in there currently is we have nothing actually checking for collision with the flame or with the barrels. And you should be able to get 100 points when you jump over a barrel. So it's not just smashing the barrel. And then the bonus, as I understand it, is just counting down once per second. And then we want to decrement lives and check for high scoring. So it's not that long of a list compared to the stuff we've accomplished already. But let's dive right back into it. All right, I think I'd like to do kind of adding this final functionality. I'd like to maybe make a new variable that I'm just going to call reset game. And so initially, I'm going to set this equal to false. Excuse me. But I want to make it to where if a barrel collides with the player, we do reset the game. So I want to kind of come down close to, I think, the player handling or the adding of like player controls, and above that, but still in the main game loop. So before for event in pygame.event.get, now everything's been drawn, everything's been updated. I want to check if reset game needs to be set. So reset game equals a function that I'd like to call, I think, like check barrel collide, or basically barrel underscore collide like this, and we'll return the variable reset game. Okay, and so for this, we'll make a new function up here by check climb and draw Kong and everything. And honestly, I just think because it involves the barrels and the players, it makes sense to get its own function. But reasonable people could say that this ought to go inside of either the player or the barrel class, and you wouldn't be wrong per se. It's just there's a lot of ways to tackle this problem, and this is how I'm going to do it. Okay. So we are going to call that function barrel collide, and let's take a look at barrel collide. It's going to be pretty straightforward overall. So define barrel underscore collide, and we're passing in this reset variable, and we're also going to return back reset at the end. Okay. So what do we do inside of it? Well, we'll say that for barrel in our list of all barrels, we will say barrels. Yes, like that. If our burl, BRL, just because I'm trying to keep it clear that this is inside a function, dot collide rect with the player dot hitbox. So don't use the overall rectangle because it's quite a bit bigger than the player. Then we will say reset equals true. Otherwise, we don't have to change reset at all. It will just pass straight through as whatever it was passed in. So the only thing barrel collide will be able to do is set collision equal to true. This reset value equal to true, and we will take care of what the reset value actually does in a future function, because reset is going to be pretty different than checking if we've collided with a barrel. It's going to do sort of different functionality for us. So why don't we come down, and the other thing that could trip a reset, the other thing that could cause it, would be any flame colliding with the player. And I think just to do this a little bit differently, but still in a pretty easy way, and let's see, barrel collide. Did I not call it barrel collide, or is it because I put a colon at the end? Barrel collide. There we go. All right. So now in the for flame in flames that we already have, because we do flame.checkClimb, let's just also do if flame.collide rect with the player.hitbox. Let's do it that way. Then we also want reset game to go equal to true. So if you get hit by a barrel or you get hit by a flame, a little sprite, we want reset game to be equal to true. Okay, and I think that's pretty straightforward right there. So I think what we should do is say, all right, we've set reset game equal to true in a couple of places. What should reset game actually do? So let's come down here and say if reset game. So if that value is true, well, we want to check if lives is greater than 0. So if lives is greater than 0, let's run a new function that we'll call reset and set that value reset game back equal to false, okay? But else, what I'm going to do is just I'm going to set run equal to false. If you want to put restart code in here, you could use this else to like draw some text on the screen and say press enter to restart, and come down in here and say if pygame.k return and lives equals 0, then restart and give the lives back. I am just going to exit the program if you use up your lives. You can boot it back up and you can play again if you want to, but that is what I'm going to do here. And then I'm going to handle what to do when the reset kind of happens. I'm going to handle what to do in this function called reset that we can take a look at now. So let's come up to barrel collide and let's define our reset function. We're not passing anything in, and that is because we are going to do a lot of stuff in here, but I am going to call globals. And I know some people whine when you pass in a bunch of globals a bunch of times in functions, but honestly, the reset is going to reset a ton of system variables that we use to play this game. And so I think it is just easiest to give it command of these variables rather than pass them all in and pass them all back. And it's going to happen frequently enough that moving it into a function does make sense. So I'm going to have this global line here, and that's where I'm going to bring in all the variables we need. But I'm going to start with a pygame.time.delay of just 1 second. So when you hit something, everything on the screen is going to freeze for 1 second, just to make it real clear that you've died. Like that's kind of how Donkey Kong plays, is when you collide with something, there's a freeze. But then what I'll do is I'll say for barrel in barrels, basically, we are going to do bar.kill. So we're going to get rid of all of the barrels, all of the flames. So for flam in flames, we're going to do flam.kill. We're going to start by getting rid of all of the sprites because we're going to repopulate them in just a second. So for hams in hammers, we are going to do hams.kill. And then the hammers one is a little bit different because those have to be created when you reset as well. So we're going to say for hams in hammer list, just like before, we're going to do now hammers.add a hammer and unpack hams. So we're actually just resetting it. We're getting rid of the existing ones and then we're resetting it to make sure it has all of them. We're going to take away 1 life, so lives minus equals 1. And then some stuff that we want to be true at the very beginning. So we want to set our bonus back equal to whatever the initial value was. We're going with 6,000. We're going to kill the player sprite, so just get rid of wherever it was. And then we're going to make the player again. So we're going to say player equals player 250 and then window height minus 130, which is where we started the player out. It's just a little bit cleaner, honestly, to make quickly or get rid of the old player, make a new one. The init stuff will run through. And so last thing is two things we haven't talked about yet. I'm going to trigger the first fireball a little bit differently from how the rest when a barrel collides with it, to be a little bit closer to how Donkey Kong works. So we're going to reset this to be equal to false when we restart. And then the victory variable, just in case it was true, we're going to reset that to be false as well. Okay, so the thing is, none of these exist in here. So we need to call global, and we're going to call global player, global barrels, global flames, global ladders. We didn't do anything with ladders. Global hammers, global first fireball trigger, which we're going to have to make in just a sec, fireball trigger. The victory, the lives, and the bonus, right? So I think that's everything that we call to. Let's see, global player. Yeah, no errors. And so basically these globals let me change these variables even though they don't exist in the context of this function, because I know they're going to be in my file. It's just easier for me to make a reset function, but I still like kind of separating it out this way. So let's take these two, first fireball victory, or first fireball trigger and victory, and let's copy them up into our game variables here in the beginning. And one thing that we haven't talked about, to obtain victory in this level, you actually have a platform that is your target. And so I think it would be useful in our dictionary to make a target as well. So basically a surface that the player can intersect with that is going to be what we're trying to get to. And so the target starts at 13. It's actually basically the same as the top platform of the Peach platform, but I'm just going to define it here. So what you're trying to get to obtain victory in the game is the platform that starts at 13 times section width, and then it is 4 times section height down from row 6. So section height, I should say up, because subtracting brings you close to the top of the screen. And I'm giving it a length of 6. So it's six section width wide. Actually, I'll say 3, so that you have to be on the left half of that platform. That way you can climb up the ladder and walk over to it, and that's when you win. Okay, and so that is the target platform. It's defined just like the other platforms, but that is the surface that if you stand on it, you win. And we're going to use that for checking for victory, which is almost the biggest thing remaining. So we have our draw extras is done. We have our reset function that we've just defined, and it should set us back to basically like, okay, you're able to restart and start playing through again. We made our first fireball trigger and our target. And so really we need to check for victory. And so let's go ahead down right under, climb and down, check climb. Let's put this victory variable is equal to check underscore victory. Okay, and so this is going to be a really easy function, easier even than barrel collide and reset. Let's define check underscore victory, okay? And let's go ahead and say that all check victory is target, which is going to be equal to the levels list, active level, and then, whatever platform is at target. So let's get that kind of tuple with 3 items in it. That list of the platform. Let's get that in this target variable. And then let's say that the target underscore rect is equal to PyGame dot rect dot capital R rect. And then the 4 coordinates for this are going to be target 0 times section width, right? That is the X starting coordinate. And then the Y starting coordinate is just going to be our target at 1. That's what we're passing in. And then let's say that the width is going to be section width times target at 2, which is the third thing we passed in. And then the height, I am just going to make it 1. You have to be on the top of the platform, so you can't just bump it from underneath with your head. All right, and so let's go ahead and say that that is the target rect. And what we actually want to return is just return if player.bottom, which is a rectangle, collides with the rectangle of, and then target rect. Okay, so that is how we are going to check for victory. The bottom of the player is standing on top of the target rectangle. That means you are standing on the platform where you're supposed to be for victory. And so that's pretty straightforward right there. That's how we are going to check for victory. So let's take a look at, all right, now we're checking for victory. What should we do if we have victory? And I'm going to come down below, I think, everything else down here. Actually, I think, yeah, we'll do it right above pygame.display.flip. And I will say if victory. Let's go ahead and do a few things. Let's screen.blit the font.render. And ordinarily, I think on victory, you would want to cycle through your levels, but I think you can tell by the 4.5-hour tutorial that I am not going to build another level with you guys from scratch. I am pretty gassed, but ordinarily, you could say if victory, active levels plus equals 1, move on through the rest of the game and keep cycling through the levels that you build. I am building level 1 with you guys. I hope you can appreciate the effort. And so let's put that just in the middle of the screen. Window width divided by 2, window height divided by 2. That is where we will blit that text. And let's go ahead and say that reset game is going to be equal to true. So just in case you win and you want to stay put and you want to keep playing, I'll also just put a comment in here like you would probably want to do active level plus equals 1 there. And then what I'll do is I'll just say lives plus equals 1 because when we do reset game, remember, it's going to take 1 life away, but you won, so we don't actually want to take a life away. And so we'll say if the score was greater than the previous high score, this is where we will set high score equal to the value of score. And then either way, we will change score equal to 0. And then we are going to make sure that we reset a few things that could impact the game. So player climbing, set that back equal to false, just on the off chance you manage to go straight from climbing to on that platform. And I kind of think that is all we have to do for victory. I think that that's going to work the way I have my game set up. I think, yeah, let's go ahead and see. What you might want to do here too, as well, is just like a pygame.delay of a second as well. But because that delay is built into the reset game function, I'm just going to move on. I think this is totally good in my mind for kind of finishing out the game. And let's see. We made that first fireball trigger, and I mentioned that I don't actually want it to boot up right when the game starts. So let's go back to fireball trigger. And let's set that equal to false. And what I'm going to do is I'm going to make the first fireball trigger trip the first time we create a barrel. So I'm going to go find barrels.addBarrel, and I'm going to say if not first _ fireball trigger. Then what I'm going to do is when I add that first barrel, I'm going to add a flame just like I would when the flame class completes. So 5 times section width. And then window height minus, I really could have copied this, I still should. Window height minus 4 times section height. And so we're going to create that flame, and then 2 flames, we're going to add that individual flame, and then we are going to set this first fireball trigger equal to true. So after this first fireball, it's going to be totally based on it's going to be completely based on when the barrels collide with the oil. But this first fireball, I think in the actual Donkey Kong game, he like throws a special blue barrel down at the oil, and then that sets it on fire and kicks out 1 flame. Not going to get quite that fancy. We're 4.5 hours in, so I'm just going to kind of spawn it when we spawn that first, what am I trying to say? Barrel. There we go. All right, one more thing to do in the counter area. So where we are counting every second, we're going to say else counter equals 0. And what we have to do now is we have to subtract. I don't know why it's in increments of 100, but the bonus goes down basically 100 value every second. And then it's else. So if bonus minus greater than 0. Oop, I don't know why I'm jumping all over the place. If bonus greater than 0, then bonus minus equals 100. And the cool part is actually we should have done this in the victory. So in victory, yeah, you get the bonus as part of your score. So here we say score plus, Yeah, score plus equals whatever the bonus is, and that's what score becomes. So this is saying score equals score plus whatever the current bonus is. And then as part of that reset, so we need to do the reset function afterwards, which we will. We're just saying reset game to true. The bonus, as far as I understand it, you get those points based on how fast you can complete the level, so it incentivizes playing through really fast, I think. If I have that wrong, feel free to correct it in your version, but I think that's what it's supposed to do. And so then I think that's enough. Let's go ahead and just check if we have the ability to get a victory, and if that will let us sort of play again and try to beat our score. So let's go. We do need to add 100 points every time you jump over a barrel. Flame has no attribute, collide wrecked. Interesting. Line 649. We did something wrong. No surprise there. Yeah, it was just a silly mistake from trying to go so fast. It's flame.rect.colliderect. So let's go ahead and play now. And hopefully I have a few seconds here as Mario to get away before the first barrel is thrown. Oh, barrel has no attribute, colliderect. Goodness gracious, did I forget .rect in 2 places? So that's inside 569, inside the barrel collide function. Define barrel collide. Yeah, if barrel.rect.colliderect. Sorry guys, this is what happens when I try to do 4.5 hours straight. Okay, let's try to get out of here before that flame spawns. All right, so here comes a flame and there goes the barrel. So I get away from the flame and I climb up. I'll grab the hammer. Maybe I can take out a barrel, get 500 points or something. Go ahead, smash that barrel and get that barrel. Nice. And get this hammer and smash-a-roo, and let's see. Oh, I actually ran into it. Oh, that's stupid. Okay. But I do get to keep the score from before, which I think is good. I think it is supposed to be the running total of everything you do with your lives. Okay, and now let's... Oh, come on. I don't really feel like I hit that barrel with my face, but that's okay. Actually, now that I think about it, did I do barrel.collide? Yeah, with the hitbox. Okay. I was going to say, did I do collide with the rectangle or the hitbox? Let's just finish this level once and see if if we can get some score that way. Oh my goodness, I'm so bad at this game. This was supposed to be, guys, a quick play test where I just showed you what the scoring looked like, but I am struggling mightily. So, okay, come on, let's beat this. We can beat this. And jump that one. Yes, I did it. I'm a gaming god. Okay, I did it. And boop, climb. All right, and climb. Okay, now I am, bang, victory. Okay, it reset. Oh, but the flame trigger right away. I think I need to set, in reset, I think I need to set some of the barrel values back to initials as well. So we should probably do barrel spawn time, barrel count, back to their initials, because it looked like the flame spawned as soon as the barrel did, and for some reason the barrel didn't reset. So let's go into reset and let's add those 2 little things. And so let's just go down. Let's make a second row for global because it's getting a little ridiculous. Barrel underscore spawn time. And then let's also do barrel underscore count. Okay, that should be fine. I kind of liked the victory. I kind of liked the scorekeeping and the resetting. I'm really satisfied with that. I genuinely think we just need to figure out how to add 100 points every time we jump over a barrel. And then I am probably going to call this good, you guys. This is a ton of work. So my head jumps right to, let's make a player variable that let's just add a variable in here that says self.over barrel. Okay, and let's set it equal to false initially. And the easiest thing I can think here is to say self.landed equals false. Here at the end of this, to just say if self.landed, then self.over barrel equals false. Okay, and that way we'll reset it every time we land. But what I will say is, let's see. If not self.landed, so that means I am in the air, and self. Do we have a rectangle underneath the player yet, or did we just do that inside of the barrel collide function? Yeah, let's move this into the barrel collide function because in a way, checking to intersect with the barrel as you jump is sort of like a barrel collision. So let's do this. Let's say if the player is landed, then player dot over barrel is false. And you could argue leaving that in the player update function is fine. But we already have a what am I thinking of? Not barrel collide. But we check underneath the player for climbing down, right? I don't know if making check climb makes sense. Let's grab this under rectangle and let's copy the same rectangle in here, okay? So let's just say that is under for this function, but if not player landed, that means the player is in the air, and under dot collide rect with the barrel. So we're gonna need to move these up. Sorry if it seems like I'm going a little off script. It is because I forgot to include adding 100 points in my original notes. So we are going a little off script. But let's say if not player dot landed. Ooh, okay, we can do an elif here. So we can say if the barrel collides with the player, we need to reset. But then let's say elif. This means we didn't collide with the hitbox. So elif not player landed and not player dot over barrel. So if we set it already, then we are saying, okay, so we weren't already over the barrel and the player didn't already land. Let's say, and the rectangle under the player collides with whatever barrel we're currently checking. We want to do two things. Player dot over barrel is equal to true, and then score plus equals 100. I know I said it's not great practice to call globals in a bunch of places, and truthfully, this is a little bit confusing to call global here, reference score, and not just pass it in, pass it out, but man, I am tired. Okay, so let's test that. I hope we can get 100 points for clearing a barrel, and hopefully we can play through this once or twice here, get a decent score, and then we can call it a day. So let's do a little quick play testing, all right? So I should get 500 for smashing a barrel. Let's see if I can smash this one. Yep, 500 for that. Now let's try to jump over a barrel. It gave me 200, and there. Okay, it gave me 100 there. I'm not sure why it gave me double points. Oh, and I hit it that time. Okay, I'm gonna try to finish. I'm gonna try to get the points that the bonus allows me, and then I am going to see if it lets me replay, and then I am gonna leave you guys with a completed project. All right, so we have 900 points. We are jumping. 1,000 points, sweet. 1,100 points, nice. And 1,200 points. All right, let's get to the victory platform. Get our, should be like 3,400, 3,300. Yeah, so top was 4,600 because we had a lot of time. So now if you finish it very, very quickly, you get a lot more points. Oh, this must be the, okay, last thing I promise. That ladder, it looks like it's colliding with the player rect and not the hitbox. So let's go to check climb. And I think what we want is player.hitbox.collide rect. That'll be much more fair because this was kind of weird. It was like I was climbing. So if player.hitbox.collide rect and not can climb, player blah, 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 blah. Pretty good. Okay, I think I'm happier with that. Let's see now. Because I think that was a little too generous. I was able to climb a ladder I was barely touching. Now, yeah, I have to be much more central on it. So hopefully, yeah, okay, that solved that problem. It looked like it solved that problem. We were just colliding with too wide of a rectangle. But okay, Guys, this is full classic playable Donkey Kong. We have fire sprites that chase you. We have barrels that follow the way down the map. We have hammers you can grab and smash barrels. We have this animated little sprite that runs up and down the platforms. We're procedurally drawing the platforms and the ladders using PyGame's native drawing tools. You have the ability to create more levels. We have scoring. We have high scoring. If you were to take this the extra mile, I would recommend adding some sound effects. I don't want too much music or sound effects on this tutorial because I have had YouTube strikes for using copyrighted like Halo music in the Halo Space Invaders that I did. And so I would like to avoid using copyrighted audio. I hope you guys like this project. I cannot believe how many people liked the 4.5-hour Pac-Man project that we did. I can't believe Lemaster Tech is at 5,000 subscribers. If you are still watching at this point, I appreciate you so much. I cannot wait to see what happens with the channel in the next few years. Thank you guys so much for watching. Thank you for your support. As always, leave any questions, comments, or projects you'd like to see in the future in the comments section on this video. Don't forget to leave a like. If you made it this far and you didn't leave a like, I don't know what I can do to get a like out of you. Please be sure to subscribe to the channel. It helps me grow so much. You have no idea. I appreciate the heck out of every one of you. Thank you for watching. Until next time, bye.